dear class 10 students, good evening to you all. Hi Sad. Yes. How are you all? Hello everyone. How's your exam preparation going? I hope it is going amazing and in full bloom as your exams are starting from 17th February. Yes, my dear students. Good morning. It's good evening, Sad. It is not morning. Did you wake up just now? Okay. So, in this live, what we will be discussing? We will be discussing metals, non-metals, carbon and its compound. These are very important and most top scoring topics or chapters of your chemistry portion, right? Good evening, Ananya. Hi, Yuvan. So, let's start, shall we? The first chapter is metals and non-metals. So, what are metals? What are metals? Metals are those substances that have luster, that are hard, they are malleable and ductile. What is malleable and ductile mean? So by malleability and ductility we means that they can be beaten down into thin sheets. Malleable means you can break them down into thin sheets. You beat them down into thin sheets. That is malleability. And what does ductility means? Ductility means you can draw them into thin wires. Draw them into thin wires. Clear? Metals are good conductor of electricity. Yes, that is different. They are not homogeneous. Homogeneous is alloys. That we will discuss later on. Yes, thin sheets and thin wires. Correct. They are good conductor of heat and electricity. Metals are. Why? Because metals have free electrons, right? Metals have free electrons, and due to these free electrons, they are good conductor of electricity and also heat. Clear? They are sonorous. That means they produce sound whenever you hit them. Whenever you hit any metal, it will produce a sound. Will produce a sound. So Kunal, stay with me. We are solving two important chapters, so duration is a little long. I don't know the exact duration now, I can't tell you that. Yes, metals are also electropositive. That means they donate electrons very easily. They have high melting point. Yes, correct. They have high melting and boiling point. Clear? They are electropositive. That means they can donate electrons. Now there are some exceptions. Not all metals follow these physical properties. What are those exceptions? Those exceptions include sodium, potassium. They are metals but they are extremely soft, right? Mercury, which is also a metal, but it exists as a liquid at room temperature. Cesium, gallium, they are also metals but they have really low melting point. They melt on the palm of your hand. Okay, only that much heat is more than enough to melt them. That means they have very low melting point. Hi Thanu. Okay, now let's talk about non-metals. What are the physical properties of non-metals? Non-metals are soft, right? They are brittle. That means you can, if you hit them hard, they will break down into powder. They are dull, non-metals are dull, and they are bad conductors of heat and electricity. Yes, they are bad conductors of heat and electricity. Hi Sahina. Electropositive metal and one metal which shares electrons like carbon. See, that depends on their electropositive nature. Some metals are highly electropositive. They will donate electrons on their own. For some, you need to give some little energy, right? Metal with metal form covalent bond though. Okay. Hi AI powered. Hello everyone. Okay, now non-metals, they are bad conductors of heat and electricity as they do not have any ion electrons. Basically no electrons for the electricity conduction. That's why they are not good conductors of electricity, right? See, the basic difference is, the one who asked this question, the basic difference is electropositive are metals and your non-metals are electronegative. Carbon is a non-metal. It is electronegative, right? It is less electronegative, that's why it shares electron, because it cannot become an anion and cation. We will discuss all that later on in carbon and its compounds, okay? Okay. Now, there are some exceptions to non-metals also. What are those exceptions? Iodine, right? Non-metals are really dull, but iodine is a non-metal, yet it is highly lustrous. Then we have graphite, which is made up of carbon. Carbon is a non-metal, right? Carbon is a non-metal, and even it is a non-metal, it is a very good conductor of electricity. Why is that? Because it has one free mobile electrons. It has one free electron. Graphite has one free electron, and due to this one free electron, it is able to conduct electricity. Diamond, it is also an allotrope of carbon, and it is exceptionally hard. Non-metals are supposed to be what? Soft, right? But diamond, which is a non-metal, which is made up of non-metal carbon, it is exceptionally hard. Kids, do not fight here, okay? What is going on? Yes, bromine is liquid non-metal. Clear. So you know all the exceptions. Now let's move on to let's start with the reactivity series. Now this is a series of elements in which elements are arranged in decreasing order of their reactivity. The more reactive elements are placed at the top of the reactivity series, and as you go down the reactivity series, the elements have decreasing reactivity, right? It is a decreasing order of reactivity series. Decreasing order of reactivity actually. So when you are going down the reactivity series, the reactivity of these metals or these elements decreases. Clear? So we'll start with potassium. This is a mnemonics to remember it. Okay? Hello Mikasa. Diamond lustrous. Yes, diamond is shiny, but it doesn't have a shine of its own. Luster means they're shining on their own. Diamond is shiny because you polished the diamond. That's why it is shiny, not because it is originally shiny. Okay? Okay. Now, we'll start with the mnemonic. The mnemonic says, please stop calling me a careless zebra. Instead, try learning how copper saves gold platinum. That is the mnemonics for learning the reactivity series. So repeat with me. Please stop calling me a careless zebra. Instead, try learning how copper saves gold platinum. Clear? So what does please means? Potassium. Stop sodium. Calling calcium. Me magnesium. A aluminum. Careless carbon, zebra zinc, instead iron, try tin, learning lead, how hydrogen, copper saves silver, gold, platinum, Pt. Clear? That is your reactivity series. That is your reactivity series. But I forgot why hydrogen is a part of the reactivity series being a non-metal. Ma'am, please tell us. Because it is a reference, my dear kids. It is a reference. It is a reference. For example, let me give you an example. In maths, right, you have a reference. 0 is your reference point. Anything that is lying to the, let's say, anything that is lying to the right of 0 is positive, and anything lying to the left of 0 is considered negative. Clear? Similar to that, hydrogen is there as a reference. Anything lying below hydrogen is anything lying above hydrogen is more reactive than hydrogen, and anything lying below hydrogen is less reactive than hydrogen, right? So it can displace, any element lying above hydrogen can displace hydrogen from its compound, right? Now hydrogen forms what kind of compound? Acids, right? Hydrogen forms acid, HCl, H2SO4, HNO3, right? So the elements that are lying above hydrogen, they are so much reactive that they can displace hydrogen. Now if you displace hydrogen, that means you take the place of hydrogen. These elements will come in place of hydrogen, and hydrogen gas will be evolved, because alone hydrogen will not suffice. It will react with the second hydrogen and will form H2. Then hydrogen gas will be evolved. Now the elements that are lying below the hydrogen, they are less reactive than hydrogen. That means if you react them with any compound of hydrogen, they will not evolve the hydrogen gas. They will not evolve the hydrogen gas. Why? Because hydrogen is more reactive than all of these. Because hydrogen is much more reactive than all of these. Copper, silver, gold, platinum. Clear? This is the purpose of keeping hydrogen there, even though it is a non-metal. Okay. Hi Divyanshu. I hope your doubt is clear. Next, now let's talk about the chemical properties of metals. That means the chemical reactions shown by metals. Now what are the reactions that metals show? Firstly, the reaction is, yes, reaction with oxygen. When metals react with oxygen, we get metal oxide. Now these metal oxide can be of two nature, either basic or amphoteric. Basic means, so why are we calling them basic or why are we calling them amphoteric? Because when metal oxide combines with water, we get a base. We get either a base or an amphoteric oxide, right? Amphoteric means these oxides will react with both acids and bases. And these amphoteric oxide means these oxides will react with both acids and bases, right? And metal oxides are basic in nature and amphoteric, right? Two things. They can be basic or amphoteric. Basic, why? Because when metal oxide combines with water, they form a base. Now what are these amphoteric oxides? You have three: zinc oxide, aluminum oxide, and lead oxide. These three oxides are amphoteric in nature. Always remember it. These three oxides are amphoteric in nature. Yes, correct. Now next reaction that is shown by metals is displacement reaction. Now what is displacement reaction? Displacement reaction means a more reactive metal. You remember the reactivity series? Please stop calling me a careless zebra. Instead try learning how copper saves gold, platinum. Clear? Yes. So the question is, what are you typing, Avdesh? The question is the metals that are more reactive. What is displacement reaction? That is the question. A more reactive metal will displace a less reactive metal from its compound. A more reactive metal will displace a less reactive metal from its compound. That is a displacement reaction. For example, here between zinc and iron, zinc is much more reactive than iron. Why? Because it lies above iron in the reactivity series, and because of that reason, it will displace iron from its compound, iron sulfate, and form zinc sulfate and iron. Next reaction is reaction with acids. So majorly we will be dealing with three acids, which is hydrochloric acid, sulfuric acid, and nitric acid. Now these two, simply when metals react with acids, we get salt plus hydrogen gas is evolved. plus hydrogen gas is evolved, right? But for nitric acid the case is little different. Okay, for nitric acid the case is little different because it is a strong oxidizing agent. It is a strong oxidizing agent. That means it supplies oxygen. Oxidizing agent means it supplies oxygen. Now if it will supply oxygen, we have hydrogen, right? We have hydrogen, and if it will supply oxygen, we will get a water molecule. We will get a water molecule. So instead of getting hydrogen, what do we get? We get water. Instead of getting hydrogen, we get water. So these reacts normally, we get a salt plus, yes, it is a good oxidizing agent. Yes, it is a good oxidizing agent. Clear? Because it is a good oxidizing agent, it will oxidize the hydrogen gas evolved to water. Okay, and because of that there is no hydrogen gas evolved. Okay, there is no hydrogen gas evolved. Now what is happening? So there are two exceptions to it. Two metals are there, magnesium and manganese. Only these metals evolve hydrogen when treated with nitric acid. Why? Because these are much more reactive, and before the nitric acid converts the hydrogen, before the nitric acid converts the hydrogen to water molecule, they will come and take the hydrogen away. They will come and take the hydrogen away. Okay, only in these two cases hydrogen gas is evolved. Only in these two cases hydrogen gas is evolved. I hope it is clear to you all. Hi, hello everyone. Hello Abdesh. What is your name? That is Yugani. Yug. Can I call you Yug? Arey, hi. Hello. I was, yeah. What do you want, Divya? If you came first rank, yes. What do you want? Want a laptop? Or I don't know what do kids want these days. At my time we wanted a laptop. Okay, now how do metals react with water? How do metals react with water? Just give me a minute. Now, how do metals react with water? So there are 5 cases majorly on how metals react with water. Some metals are very reactive. Some metals are very reactive. Yes, in case of nitric acid, a salt is formed. Correct. Let me correct it. Yes, salt is always formed. Always forms a salt. But there is no hydrogen gas in case of nitric acid. In case of nitric acid, there is no hydrogen gas evolved. Clear? There is a salt formed. Again, whenever metals and acids react, we get a salt. But that hydrogen differs. If we are having HCl and H2SO4, hydrogen gas is evolved. But if it is nitric acid given, no hydrogen gas will be evolved, except if it is magnesium and manganese. Except if it is magnesium and manganese. Aqua residue, that's a part of the chapter which I forgot. See, we are just discussing that aqua residue. It is a 1:3 mixture of, that is 1 parts concentrated nitric acid, 3 parts concentrated hydrochloric acid, right? You mix it, take 1 part concentrated nitric acid, 3 part concentrated hydrochloric acid. Clear? And then what do? You mix that, right? Make a solution of it. Now after you make a solution of it, what is the purpose of making this? The purpose is to dissolve gold, silver and platinum. The purpose is to dissolve gold, silver and platinum. Clear? Yes, the purpose is to dissolve. Yes, if you do score good, you can get a laptop. Hello Abdesh, does pH 0 of a substance possibly be? Yes, obviously 0 pH is possible. That is the our stomach acid is around 1, right? But you have concentrated sulfuric acid. Concentrated sulfuric acid has a pH of 0%, which is like 100% concentrated. If you have 100% concentrated sulfuric acid, its pH is 0. Its pH is 0. It is that strong of an acid. Okay. Now aqua regia is a 1:3 mixture of 1 part nitric acid, concentrated nitric acid, 3 part concentrated hydrochloric acid. It is highly corrosive. The other name is royal water. We also call it royal water because it is used to dissolve these metals. It is used to dissolve these metals. So sometimes if you want to clean it, so what some people do, they put these metals, these silver, gold, platinum jewelry in this mixture, and what happens, the upper layer gets cleaned, the upper layer gets dissolved, and thus the underneath layer, which is very clean, it shows, you know, you see that your jewelry is sparkling again. Yes, I hope it is clear. Now, how do metals react with water? So there are 5 cases. Some metals are very reactive. They will react with cold water. For some metals, you will need to increase the temperature. That means you need to give hot water, right? And for some metals, the temperature need to be higher than, greater than 100 degrees Celsius. Greater than 100 degrees Celsius. That means you react them with water vapors. You react them with water vapors. Clear? So the metals that are more reactive, that are the most reactive, that are lying at the top of the reactivity series, sodium, potassium, calcium, they react with cold water. They react with cold water. Again, whenever a metal react with water, we get metal hydroxide. We get metal hydroxide plus hydrogen gas is evolved. Plus hydrogen gas is evolved. For cold water, the cases are same. Then some metals react with hot water, like magnesium reacts with hot water, right? Magnesium reacts with hot water. And whenever a metal reacts with water, we get metal hydroxide and hydrogen gas. But there is an exception. When metal react with water vapors, that is steam, it has a much greater temperature, greater than 100 degrees Celsius. When some metals, for example, aluminum, iron, these metals react with steam, what happens? Water vapors, we get metal oxide, not metal hydroxide. We get metal oxide. Why metal oxide? Because at that great of a temperature, greater than 100 degrees Celsius, only oxide will survive, okay? Oxides are much more stable at higher temperatures than hydroxides. Okay, hydroxide can decompose into oxides and hydrogen gas can be evolved, right? But if you have a metal oxide, so that's why what happens at higher temperature, metal oxides are getting formed, not metal hydroxide. Why? Because metal hydroxide will decompose into metal oxide and hydrogen gas. Clear? Are there videos of you explaining each one of the activities in the textbook? I have a live schedule. Let's meet. We will see in the live. I have all the there. We will be talking about all the activities. Okay. Then fifth category is of metals which do not react with hot water, cold water or water vapors. They are not reactive at all, like lead, copper, silver, gold, platinum. As these are non-reactive metals, they will not react with hot water, cold water, water vapors, okay? Anything you put them on, they will not react with it, okay? That's why we use these kind of jewelries in everyday life. Okay. Next is the chemical reactions of non-metals. What kind of chemical reactions are shown by non-metals? They show very less reaction. For example, when non-metals combine with oxygen, we get non-metal oxide. Now, what is the nature of these non-metal oxide? They are either acidic they are either acidic or they are either neutral. Some non-metal oxides are neutral, some non-metal oxides are acidic. Majorly they are acidic, only 5-10% are there that will be neutral, okay? So always remember, metal oxide can be basic or amphoteric, and non-metal oxide can be acidic or neutral. Okay. Now what is the nature of non-metal oxides? As these are, non-metals are electronegative, right? They want to gain electrons. Non-metals want to gain electrons. They do not want to lose electrons, they want to gain electrons. Okay, now what will happen if they want to gain electrons? We have water, we have acid. Water and acid, again, acid also are electronegative. They also want to gain electrons. Acids also have the tendency to gain electrons. Water also have the tendency to gain electrons. So all wants to gain. Non-metal wants to gain electrons, acid wants to gain electrons, water wants to gain electrons. Now all wants to gain something. No one is donating anything. Any kind of bond formation happen if one is donating and the other is accepting, right? Only then a bond formation will happen. But if all are of the nature that we want, no bond formation will happen. That's why non-metals do not react with water or acids. Non-metals do not react with water or acids. Hi Naveen. Acidic or neutral? Stella, Jovin, everyone will ask it. I'm gonna clear it once. 1:3 mixture of concentrated nitric acid, 1 part concentrated nitric acid, 3 parts concentrated HCl, concentrated hydrochloric acid. This is your aqua regia. Clear? Now non-metal oxides are of two nature, acidic and neutral. Acidic means carbon dioxide, nitrogen dioxide, sulfur dioxide. Neutral, carbon monoxide, nitrogen oxide, water. These all are neutral. Now what happens if metals and non-metals react? If metals and non-metals react, the kind of bond that is formed is ionic bond, or you can say electrovalent bond, okay? Because metals have the tendency to donate electrons, right? Metals wants to donate electrons, and non-metals wants to accept electrons. They want to accept electrons. Perfect, right? One is willing to give something, the other wants to take something, right? A bond will form, right? I am giving you something, you are taking something from me, a bond is formed, right? Now this bond is formed by transfer of electrons. This bond is formed by transfer of electrons. This kind of bond is called ionic bond. The bond that is formed by transfer of electrons is called ionic bond. Clear? Now these ionic bond, ions are getting formed. There is a cation, that means a positively charged ion. This is a cation. An anion, which is a negatively charged ion. And a bond formation happen between, positive and negatives attract very strongly. Example, you have seen in magnets also. North pole attracts strongly with the south pole, right? Not north-north. So that means opposites attract. Na positive and Cl negative. A bond, very strong bond, which is called ionic bond, is formed between them. Okay, that is the force is electrostatic force of attraction. Why? Because there is a positive and negative ion, right? In between them, the force is called electrostatic force of attraction. Clear? Thus, ionic bonds are very strong. Strong bond with high melting point. Yes. Reaction non-metal to salt solution, the most reactive. Non-metal less reactive metal from salt solution, for example. Okay, Prakash. Now the bond formed is ionic bond. The compounds are ionic compounds. What are ionic compounds? That have ionic bond, okay? That are formed by ionic bond formation. Clear? Those are called ionic compounds. 6 are remaining. Can you define, what do you want me to define, Yuv? Just tell me what you want me to define. An ionic bond you want me to define. An ionic bond is formed by transfer of electrons, there is a cation, there is an anion, there is an electrostatic force of attraction between the positive and negative ion, and the bond formed is called ionic bond. The bond formed is called ionic bond. Clear? Now what are the properties of these ionic compounds? These ionic compounds have some properties. They are crystalline in nature. They have strong force of attraction. Which force of attraction? Strong force of attraction. The name is electrostatic force of attraction. They have electrostatic force of attraction. They are brittle. That means if you apply pressure, they will break down into pieces. They will break down into pieces. They have high melting boiling point. They are good conductor of electricity. Why? They have ions, right? They have ions, but only in molten state or aqueous solution. Only in molten state or aqueous solution, because in solid state ionic compounds do not have any ions. Because in solid state ionic compounds do not have any ions, but when you melt them or when you make a solution of them, ions are there, and because of these ions they will conduct electricity. Because of these ions they will conduct electricity. They are soluble in water because water is polar like them. Polar means poles, pole, north pole, south pole, right? So similarly, in water you have poles. One is slightly positive charge, and one has slight negative charge. Oxygen is more electronegative, hydrogen is less electronegative. So oxygen have a negative charge, hydrogen have a positive charge. These are poles. Poles are getting created. Clear? Ionic compounds also have poles. There is a positive ion, there is a negative ion, right? So like dissolves like. So that's why they are soluble in polar solvents only, because they are similar in nature. They are similar in nature, right? In classes also. Hold on a second. Oh, wait a minute. I have some doubts, I guess. Let me answer your doubts. Okay. You want me to define ionic compound and bond. So ionic bond is formed by transfer of electrons, okay? Between two atoms, we have a positive ion, a negative ion. Positive ions are called cations, negative ions are called anions. And the compounds that are formed by this ionic bond, that have ionic bond, are called ionic compounds. Okay? Asang, that's your name, Asang Maurya. Ionic compound bond, ma'am, take my name. Ma'am, difference between ionic bond and covalent bond. So if difference between ionic bond, covalent bond came, just simply write ionic bond formed by transfer of electrons, covalent bond formed by sharing of electrons. Electrostatic force of attraction, thus very strong, ionic bond. Covalent bond formed by sharing of electrons, very weak interactions, weaker than ionic bond. Clear? Then both are brittle, that is one thing. I conduct electricity because there are ions. Conduct electricity in molten state and in aqueous solution. Ionic compounds do not conduct electricity. Okay? Why? Because there are no free ions or electrons. Simple. 3 points are more than enough. Oh, somebody answered your question. 3 point NA K is exception, right? The 3 point. Which 3 point exception? 3 point. 3 point. Brittle. Na and K, they are very soft. Sodium, potassium. Hold on a second. We are talking about ionic compounds. We are not talking about individual atoms. We are not talking about sodium or potassium here. We are talking about NaCl or KCl. We are talking about these things, not individual atoms, not individual metals. Clear? That is a different thing. They are metals, okay? They are very soft. Hello, Mazali. Peak. What are you not understanding, Anjali? Smita also did not understand. So when you are spamming, so do tell me, ma'am, I did not understand this thing or that thing. Only then I will be able to answer your doubts. Okay, if you just spam it, not understand, okay, don't understand it, but tell me what you are not understanding. Smita, stop. Smita, don't do that. Paid actors. What is your doubt, Smita? Metal high melting boiling point, non-metal low melting boiling point. Ma'am, what's bleaching powder? Or please clarify. Old NCERT says, new NCERT says. Yeah, written the same. Okay, so bleaching powder is this, na? This is bleaching powder, calcium oxychloride. Calcium oxychloride, that is bleaching powder. Hi, Marine. You came late, Anjali. Tell me what were your doubts. Okay, so they are soluble. Done. Now minerals and ores. Minerals and ores. Baking what? Baking powder, baking soda. Whose formula are you asking? Baking. Baking powder. Okay. Washing powder, Nirma. Okay. Where? Okay, we have space here. Baking powder is a mixture of, it is a mixture of sodium hydrogen carbonate, or you can say baking soda. When you mix baking soda with an edible acid, any edible acid. Normally the acid we use is tartaric acid. The acid that we use is tartaric acid. When you have baking soda and any acid, any edible acid, this is the mixture. This is called baking powder. It is majorly used for baking purposes because baking soda is basic, right? And any basic thing that you eat, it has this bitter smell, right? Bitter taste. So to eliminate that bitterness, you use this baking powder. Okay. This also serves the purpose, but also it has a very sweet smell, sweet taste also. Okay, this is the formula of baking powder. This is baking powder, mixture of baking soda and an edible acid. Yeah, Nirma is not, I don't think it comes anymore. The brand has stopped making it, or have they rebranded it? I don't know. Free more marks in science. So Anjali, if you want to get more marks in science, please start studying science first of all and study it sincerely. Revise it, study it, okay, because before that I believe you have maths and language paper, English, and then after that you have science, right? So till then do not skip the revision. Do the revision till as you start preparing for your maths, right? 14, 15, whenever you are starting seriously preparing that. Till then focus on science, okay? Every day practice formula sheets, focus on the reactions. In biology, the diagrams are very important, okay? There are so many definitions, so many words in biology, they are very tough to learn, but if you revise them every day, you will become habitual of it, okay? So every day revise formula sheets, reaction sheets, and diagrams from biology. And then after that you should have these summary notes, a 1-page note of each chapter. Make them if you have time now, so you can make 1-page note of all the chapters, one chapter 1 page, okay, so that you revise them. It won't take more than 1 or 2 hours if you sit down and start making it, and then every day revise it, and after that focus on the last 10 years PYQ and last 5 years sample paper. That is more than enough, okay, and then you'll score good marks in science. There will be 3-day marathons. We have 3 days for science board exams. Yes, there will be a 3-day marathon, so you should be prepared because we are prepared. Yes, science, there are repeated questions, but since this year the pattern has slightly changed, so there will be some competency based questions. They will not be straightforward. Directly they won't be asking anything, but they will be checking your knowledge, if you know the concept or not. Anjali, chemistry is not tough. See, chemistry is very easy if you study it in methodically, okay? Sorry, conceptually you study, there is so much logic in there, so you can easily understand. Don't worry. Science repeated questions. Okay, we'll start. We have questions, okay? After this, we will be doing questions. So let me finish it. Mineral quartz calcite example of ore is iron. Yes, correct. correct. So Evangeline, right? Am I pronouncing your name correctly, Evangeline? We will do the repeated questions after this revision, okay? We are almost done. So wait for some time, my dear. We will do the questions. And Anjali, if you have any doubt in chemistry, do ask me. I will answer each and every of your doubt, okay? Hi, Shant. But formula is so tough. Which formula? Formula making is very easy. If you know the valencies, if you know the symbol, you can make any formula. And plus in 10th class, only easy formulas are there. Hi, Amit. What about carbon chapter? We will be doing carbon chapter also. Yes, we will be doing carbon chapter. Which formula you find tough? Ask me. I believe there are only, I've done one live, I've taken one live of all the important chemical reactions. So it has around 40 chemical reactions. There are all the formulas and names are written. Go watch it. After watching it and making the list of those reactions, you will not need to go anywhere else for other reactions, right? All the reactions are covered there from your 10th syllabus and you do not need any much more. There 90 to 95 portion is covered there, okay? 2-5 reactions are there that maybe examiner wants to surprise for the topper students, so do not worry, but your major portion will be covered there. So if you just follow them, all the formulas are written there, all the important compounds are there, okay? From there you can remember the formulas. It is not chemistry, even though underspelling take too much time. It is not tough, okay? Weightage in chemistry, which chapter? Highest weightage chapter is your these two chapters, metals, non-metals, and carbon and its compound. These two chapters. Okay, so let's start. Alum, you do not need to remember the formula of alum. Trust me, you do not need to remember it. 3-4 chemistry equations of carbon chain. Yeah, they are hard, I know. We will memorize them today, do not worry. Okay. Hi, Samosa. Okay. Divyanshu, alum's formula will not be coming in your exams. No need to memorize it. Now let's start with minerals and ores. What are minerals? What are ores? So minerals are elements or compounds. They are compounds actually. They are compounds of metals. They are compounds of metals from which you cannot extract the metal, okay? For example, salt, clay, marble, these all are minerals, okay? They are minerals of aluminum, they are minerals of calcium, right? But you cannot, from these you can, but there are some minerals from which you cannot extract the metals directly because the amount is really less, okay? They exist naturally in earth crust, but the amount of any metal is very less in them. So you cannot extract the metal profitably or conveniently from them, okay? Okay. These are minerals. For example, salt, clay, marble, they are minerals. Ores, what are ores? Ores are minerals. Ores are minerals. These are those minerals from which any metal. Why? Because they have high percentage of that metal. They have high percentage. These have around 0.5, let's say 0.5 to 1% or 2% of metal is there. And these have around 20, 30, 40% metal is there in that particular compound, okay? If this much amount is there, you can extract it using any industrial process. We can extract the metal from them, okay? That is called ores, from which metals can be extracted profitably and conveniently. They are called ores. For example, aluminum ore is called bauxite. Aluminum is extracted from bauxite. Iron is extracted from hematite, right? Bauxite, hematite. Sodium metal is extracted from rock salt. These are rocks actually, salt rocks that are found in the earth crust actually. You dig it and there you find it. Now what is gangue? Gangue is called, what is gangue? Gangue is called it is the unwanted impurities. Alongside ore, there will be some impurities that you do not want, right? Obviously, there will be dust, rocky particles, sand, you know, all these things. These are called gangue. These are called gangue. Now the reactivity series, whenever you are extracting any ore, so you need to identify how reactive the metal is. How reactive the metal is. For example, from potassium to aluminum, these all are metals of high reactivity. These all are metals of high reactivity. Okay, they are found in as their molten. They are found as their chlorides. They are found in the form of chlorides, and from their chloride ores we extract them. Okay, how do we extract them? By the process called electrolytic reduction. Electrolytic reduction. Then you have metals of moderate reactivity, which are not that reactive but not less, not highly reactive but not less reactive. In between they are lying. Zinc, iron, lead, right? They either exist as their carbonate ore or sulfide ore, and from there you extract using either roasting or calcination. Okay, if carbonate ore is there, you use calcination. If sulfide ore is there, we use roasting. Clear? Then you have metals of low reactivity. They generally exist as their sulfide ores. From sulfide ore, again you do roasting, then you get the metal, then you do one more thing. We do refining. We do electrolytic refining. So once you get your metal, you have a sulfide ore. From that sulfide ore, you do the roasting. After roasting, get the oxide, then do the reduction, and then finally you get the metal. It has some other impurities also. Now, how do you purify this metal? It is done using electrolytic refining, right? See, the difference is in electrolytic reduction, we are extracting the metal. We have the ore, and then we extract the metal using electrolytic reduction. In electrolytic refining, we already have the metal. We already have the metal with impurities, not ore. We have the metal, and we want to purify that metal. And that purification is done using electrolytic refining. Now, these are the least reactive metals. They will exist in their free state. That means they will exist as gold, silver, platinum, simple. You can just take them out, simply purify them, and then you will have your metal. No other process is required. Anjali, you need to score top marks, not passing marks. I believe it is around, if you have 80 mark paper, then 20 to 25. Anjali, that it do not no, it is not. Electrolysis is different. Electrolysis means you're passing electricity and a reactant or any compound is getting decomposed. Decomposed means you are breaking that particular compound in two or more products. Okay, that is electrolysis by passing electricity. Electrolytic refining means you're purifying a metal. Different thing, na? You're purifying a metal here. There you're taking a reactant and then you're passing electricity and you're breaking it down into multiple products. You're breaking it down into multiple products using electricity. That is electrolysis. All these things are different. One thing is common in between them, electricity. Electricity is common between them. It is finding a reduction, I mean, in so refining, see the difference, kid. Refining, when you're refining something, basically you're purifying something you already have. For example, whenever you do refining of what? Have you ever seen, or whenever you get the honey, right? Honey straight from the bee hive, right? From the beehive, if you have found it. So you refine it, right? Initially it is coated in this bee wax, then from that you refine it, right? What do you use? You use sieve, chalni type, right? And from that you sieve it and then you get your pure honey. That is refining. You're refining something, right? And the next is reduction. Electrolytic reduction, that means you are extracting. Reduction means extraction. Simple. Actually, it is in the process. Reduction means you are reducing the metals. You have the metals in form of their chlorides, in form of their molten chlorides, you have the metals. You do the reduction of these metals. That's why they are observed. They are actually, you get the metals at cathode. That's why you get the metals at cathode. Okay, you get them at cathode. Why? Because you do the reduction of the metals. You do the reduction of the metals. From there you have molten chlorides. From there you do the reduction, and after that you get your pure metal. Okay. Okay, questions were there actually. Let me answer it. Redox, what? Now how do you extract the ores? Firstly, you do concentration. Now what is concentration? So concentration means that you have the ore, from there you remove the impurities, you remove the gangue particles, okay? The impurities like dust, sand, rocks, okay? You remove all these impurities, and this process is called concentration of ores. This process is called concentration of ores. Clear? Next is you have three type of metals, right? Metals of high reactivity, metals of low reactivity, metals of high reactivity, metals of moderate reactivity, and then metals of low reactivity. Clear? Metals of high reactivity, they exist in form of their chlorides. They exist in form of their chlorides. From chlorides you do electrolysis, electrolytic reduction, right? You do electrolytic reduction, and after that you get your pure metal. Metals of moderate reactivity, they will either exist as carbonate or sulfide or carbonate, or you do calcination, which is heating in. What is calcination? Calcination means heating in absence of air or in limited supply or absence of air, no oxygen. Carbonate ore are getting converted into oxide ore by the process called calcination. What is calcination? Means heating of ore in absence or limited supply of air. That is called calcination. After doing calcination, we get oxide, metal oxide. Then again, after oxygen, we have oxide of metal. That means oxygen with metal, right? If you want to remove the oxygen, removal of oxygen is called reduction. You will do the reduction of metal, and after doing the reduction of metal, we get the metal. After that, do the purification of metal, then you get the pure metal. Then if you have the sulfide ore, we do roasting. What is roasting? Means heating the ore in presence of excess air. In presence of excess air is there. Okay, if you heat it in excess of air, what will happen? You will get sulfide ore will convert into oxide ore, and oxide ore again we do the reduction, then after reduction do the purification, and that's how you get your pure metal. Okay. The metal of low reactivity, they also exist as their sulfide ore. From sulfide ore you do roasting, that is heating in presence of excess oxygen. Heating in presence of excess oxygen, right? And then you get the metal, and then you do the electrolytic refining. Clear? When potassium sodium are put in molten core, then they burn off and become just ash. Please don't think this is a time pass message and doubt. Okay, ma'am, when potassium sodium are put in molten core, we are not putting them in molten core. We are melting them. We are just melting them. So we are just melting them till their melting point. We are not doing so much melting that they will evaporate or decompose or something. We are not heating till that temperature. We have the chlorides, right? We have the chloride, the ore of sodium or potassium. Then we just heat it till it melts. Once it's melted, we put that in the process called electrolytic reduction. I will show you the process actually. Let me just show you. This is electrolytic reduction. So you just melt it till its melting point, till you melt the sodium chloride. Okay, you have the chloride NaCl, right? You melt it only its melting point. Okay, once it's melted, you add it in the solution. Right? Molten chloride solution, right? Have one anode and one cathode. This is one anode and this is cathode. Okay, what happens actually? This is the reaction that is happening at anode, and this is the process at cathode. Reduction, this is reduction. Addition of electron is called reduction, okay? You do not need to know that, but for your reference, I'm making you, like, you know, you guys have lots of doubts in this process. This looks just like the chlor-alkali process. That is different. In chlor-alkali process, you have an aqueous solution. Always remember it, that is an aqueous solution. And here we have molten NaCl. We have molten NaCl. Molten sodium chloride solution. Why we are not using aqueous solution? Because if we use aqueous solution, you will have water, right? In water you have hydrogen. So then hydrogen and sodium will compete, and in between them, sodium, in place of sodium we will be getting hydrogen at cathode. In place of sodium, we will be getting hydrogen and at cathode. Thus, we will not be getting the metal. And that's why we do not use the aqueous solution. We use molten sodium chloride because we want sodium metal. This process is done to extract metals. Remember, extract metals. Okay. Normally, we use it for highly reactive metals like aluminum, calcium, sodium, potassium, right? We take a chloride. We melt it till its melting point. Once it's melted, we put it in this solution, electrolyte, right? Then we pass electricity through it. What happens when you pass electricity through it? Cl negative will lose its electron. This process is called oxidation. And this lost electron will be gained by Na positive, because in NaCl we have Na positive and Cl negative, right? Na positive, Cl negative. This Na positive will gain this electron, and thus form sodium. We need the sodium metal, right? We are doing this to extract the sodium metal, and this sodium metal will deposit at the cathode, This is your sodium metal. Chlorine gas will be evolved at anode. This is the chlorine gas. These bubbles are chlorine gas bubbles. Chlorine gas will be evolved at anode, and at cathode we will get the sodium metal. Why we are not using aqueous solution? Because hydrogen will compete with sodium, and at cathode we will be getting hydrogen. We do not want that happen. We want the sodium. That's why we are using molten sodium chloride solution. Remember, it is used for extracting metals. If you guys have any genuine doubts, do ask me, okay? You guys are just talking. What do you want to know actually? Next is electrolytic refining. What is electrolytic refining? Just see. Electrolytic reduction, process of extracting metals from their molten compounds. Using electricity, right? Then you have electrolytic refining, purifying impure metal. You are not extracting. You already have the metal. You already did the roasting. You already have the impure metal. You just purifying that metal using electricity. So we normally use it for moderately reactive or not that reactive. You know, moderate to less reactive metals. Only for those metals we use this process. Copper, zinc, silver, gold. Clear? So what do? We have a cathode, we have an anode. In that case, both the anode and cathode were inert. Inert means they were not reactive. Any graphite, normally we use graphite electrode, okay? But when you are doing electrolytic refining, we use one impure metal rod as anode and the pure metal rod as cathode. We use the impure metal rod as anode and the pure metal rod as cathode. And the electrolyte, this is electrolyte. The electrolyte is a salt solution, soluble salt solution of that metal. Which metal? The metal that we want to purify. Purify. This impure metal is made of what? This anode is made of impure metal rod. This cathode is made up of pure metal. Okay. Now what happens when you pass electricity through it? This anode will start breaking. Like this, and it will go in the solution in electrolyte, right? In electrolyte we have a salt solution. Let's take an example with copper. This is copper electrode. impure copper electrode, this is pure copper electrode, and this is a salt solution, copper sulfate. What happens when you pass electricity through it? This anode will start breaking. This anode will start breaking, right? Copper will dissolve in this copper sulfate solution. Copper from this rod will dissolve in this salt solution, right? From this salt solution, an equivalent amount of copper will deposit on this electrode. From this salt solution, an equivalent amount of copper will deposit on the cathode. Clear? So with time, what is happening? This rod will break down, okay, and it will vanish. It will vanish completely. The amount of time, okay, for the time you pass the electricity, this rod will keep vanishing, okay, keep disintegrating, will vanish with the time, and this rod will get thick. This impure metal rod will get thick, because all the copper from the salt solution will deposit on this, because the copper from the salt solution will deposit on this electrode. Clear? Okay. This is electrolytic refining. Okay, this is electrolytic refining, and these impurities, because we were disintegrating what we were trying to make pure metal from the impure metal, right? So all the impurities will lie below this anode, and that's why they are called anode mud. They are called anode mud. Anode mud are the impurities that were there in the impure metal rod, okay? That were there in the impure metal rod. They are called the anode mud, okay? Now let's start with the questions. Let's start with the questions, my dear kids. Can we say the metal dissolved solution form and aqueous solution, and they form the metal dissolved in the solution and forms? Actually, you can say that metal deposit in the solution, and from the solution an equivalent amount of metal deposits on the cathode. From the solution, it dissolves in the solution, and from the solution or from the salt, an equivalent amount of metal deposits on the cathode. That's what you can say. A student places a clean strip of magnesium metal into a test tube containing a blue solution of copper sulfate. This has solution of copper sulfate. Okay, he places a clean strip of magnesium. What is the expected observation? So tell me which is more reactive, magnesium or calcium? Sorry, magnesium or copper? So obviously, magnesium is much more reactive than copper. So there will be some observation. Now what is the observation? Tell me the answer. Alloys are homogeneous mixture of metals in which metals combine metals, or sometimes you have metals, sometimes you have metals, non-metals, in which they combine in a different percentage. No one is going to answer it, I believe. Okay, let me answer it. So when magnesium reacts with copper sulfate, we get magnesium sulfate and copper. Okay, now magnesium sulfate, what is the color change will you observe? The solution, this is blue colored, right? The blue color will disappear, right? So what will happen? The blue color fades, reddish brown solid deposited on the strip. This is reddish brown, na? This is reddish brown. This is reddish brown. Okay, so the blue color will disappear and there will be a reddish brown solid deposited. And what is that reddish brown solid? That is copper. That is copper. Very nice. Too much studying going in the chat section. Too much studying. Okay, Shriveni, because your answer got lost in the chatting. They all are just chatting there.
When pure metal get fused into solution to form a solution from the metal deposited in the cathode and can angle deposited in the anode.
You've an equivalent amount of metal from the salt. That is the thing. Oh, where is that metal coming from? That pure metal is coming from the salt solution, okay? From the salt, an equivalent amount of pure metal deposits on the cathode. So Ritvik, right? Ritvik, reactions you need to practice. You need to practice every day. You need to do the. You need to make a reaction sheet again. Check all the important chemical reaction that live is in there on the channel. Check it and write all those reactions down and remember. Revise them every day. Okay, only then you can remember it.
Two or more metals and a small amount of.
There is not always correct, Prakash. So mixture of, it can be a mixture. It is a homogeneous mixture of. It is a homogeneous mixture of two or more metals or metal and non-metals. So you can have metal or metal non-metal also. Both of these will be alloys. Both of these will be called alloys. Okay, it is a homogeneous mixture.
Hello Vidyavanti.
Samosa, do not drink anything. You actually, you guys should prepare well. Okay, your marks should not decide it. Okay, your worth is within you. Okay, do not let the marks decide your future. Actually, they will decide your future, but for now, do not let it. Don't think about such things, kids. Please.
How can we remember? Ritvik, I answer your doubt. Hi, Kavya. Oh, Kavya. Next question. Okay, let's move on to the next question.
Ritvik, I already have done it, kid. Watch the video, please. Go watch the live. I have completed all the 40 important chemical reactions. So just 40 are there. If you do them, you do not need to remember any other reaction.
Metal from the electrolyte.
Yes, that is correct. That is the only thing happening. Metal from the electrolyte is getting deposited at the cathode.
Easy questions. Okay, let me level it up for you.
Mikasa name Kavya. So your name is Mikasa or Kavya?
Arey, don't cry.
Don't cry, okay? One day the world will be a better place for you all. One day. Okay, let's start. Next question. Amalgam is an alloy of. This one's also easy. Amalgam is an alloy of copper and zinc, metal and mercury, sodium and potassium, iron and carbon. Answer it quickly. Because wouldn't remember equivalent salt and stuff. Equivalent salt and stuff. For take me with you, Samosa. One second. B, correct. So one metal is mercury. Whenever you have an amalgam, the other metal, one metal will always be mercury, okay? Because an alloy of mercury is called amalgam, okay? Metal amalgam. Simple. The name will be simple. If zinc is there, zinc amalgam. Sodium amalgam. Potassium amalgam, okay? Let me explain the question. What did you not understand? Magnesium reacts with copper sulfate. As magnesium is more reactive, it will displace copper from its compound, right? As magnesium is more reactive than copper, it will displace copper from its compound. We get magnesium sulfate and copper. Now copper sulfate is blue in color and we know copper is reddish brown in color. Now what will happen? With time the blue color will disappear. Why? Because copper sulfate will is decomposing, right? So basically there is a displacement of copper sulfate, right? Copper is displaced by magnesium sulfate. Now this magnesium sulfate does not have any color. So what is the color of copper? This reddish brown color will deposit on this stripe. Reddish brown color solid will deposit on the stripe. So any doubt you have, instead of typing or spamming it as doubt, just say your doubt, okay? I will answer it. If it does not got spam in good when Mercury was just a planet. Wow, your life was very good 15 years ago when you did not exist. Okay. The metals obtained from their molten chlorides by the process of electrolytic reduction are. So these are the metals which are most reactive. These will be the metals that are most reactive, right? And which among the following is most reactive? Sodium is reactive, but iron is not extracted from its molten chloride. Silver is also not reactive. Silver again. So these three are not the correct answer, calcium and magnesium. As these also lie at the top of the reactivity series, they are very reactive and you extract them using the process electrolytic reductions. Yes, B is the correct answer. Next question, the pair which will show displacement reaction. So, which pair will show the displacement reaction? For these kind of questions, follow this simple approach. If you are given options like this, check which options is repeating, which number is repeating. 2, 2, let me see. For me, 2 is repeating. So, I'll check 2, if 2 is correct or not, okay? Copper and silver. Yes, copper is more reactive, so yes, copper will displace. So I got a bit confused now. Okay, now let's check again. With 2 we have 3. Let's check 3. Aluminum and magnesium. Which is more reactive? Let me see. Please stop calling me. So magnesium is more reactive, right? So if magnesium is more reactive, it will displace. So this is correct. This is correct, right? Zinc, iron won't happen. Sodium, copper won't happen. Clear? So the correct answer is option number 2. B again. Stop. Why do you want me to stop? What are we playing something here? Okay, you want difficult questions? I'll give you difficult questions. Yes, the correct answer is B. Assertion says the solution of ionic compounds are good conductor of electricity. Reason says movement of atoms of elements take place in solution. Movement of atoms. Yes, see, ionic compounds do conduct electricity. The solution, the thing written is solution. The solution of ionic compounds do conduct electricity. Clear? Why do they conduct electricity? Because they have ions. Because they have ions. The reason is ions. Not atoms. The reason is ions, not atoms. Okay, some are answering B, some are answering C. So the reason is assertion is true and the reason is false. Assertion is true but the reason is false. The correct answer is option C. Yes, assertion is true, reason false. Correct, Karthik. Okay, need to think. Is it? Are you that all things? Need to think. Was your username all things? C. Yes, Prakash. C. Next question. The ability of metal to be drawn into thin wire. Everybody knows. So, ability of metal to be drawn into thin wire is called wires. Ductility. Malleability means thin sheet. Sonoricity means sound. Sound producing ability. Conductivity, conduction of heat or electricity. So the correct answer is option. Okay, need to think. Okay, I thought that was a previous student of mine. A, B. Yes, the correct answer is A. B is not the correct answer. Karthik. Next question. Aluminum is used for making cooking utensil. Which property of aluminum is responsible for the same? Which property? Aluminum are, so whenever you're making a cooking utensil, you need two things. You need it to have a high melting point so that it does not melt when we heat our food to a very high temperature, because we need to cook, whenever you're cooking food, you heat it to a very high temperature. Second thing is, when we have when we are giving heat to it, it should be able to conduct that heat in a good way. Okay, only then will you get the or else what will happen, your fuel will get wasted. Okay, so two things, a good thermal conductivity and high melting point. Good thermal conductivity and high melting point. Yes, good thermal conductivity, high melting point. So that is 1 and 4, option D. Correct. You all are answering correctly. Wow, you are a studious batch, I believe. Good. Yes, correct, Shriveni. Correct, need to think. It's D. Oh, Sona. Okay, Sona. Okay, next question. Which of the following oxide of iron would be obtained on prolonged reaction of iron with steam? So when you heat, when you have iron and prolonged, if you heat it with water for prolonged time, for too long time, right? For too long, prolonged means too long time. You don't know that time, but it could be more than 10 minutes, 15 minutes, 20 minutes, half an hour, okay? Something like that. So which oxide will be formed? Which oxide will be formed? Yes, correct. Hi Faizan, happy birthday. Happy birthday. So let me do the reaction. This is the reaction. If you do prolonged passage of steam through iron, what will happen? It gets converted into ferric oxide, Fe3O4. Okay? Fe3O4. Clear? Correct answer, option is C. Because this happens when you do only when you pass the water for some time. Only for some time it first gets converted into Fe2O3. But if you do too much, for example in lime water you have seen, right? When you pass carbon dioxide through lime water, we get calcium carbonate. But if you do prolonged passage of carbon dioxide, it gets converted into calcium hydrogen carbonate or calcium bicarbonate, right? So here initially it will form ferric oxide, but after some time it will get converted into Fe3O4. Clear? Hi, so again happy birthday Faizan. May God bless you. You have a good year ahead. Okay. Next question. Alloys are homogeneous mixtures of a metal with a metal or a non-metal. Which among the following alloys consists non-metal as one of its constituents? So in which of these alloys you have a metal combining with a non-metal? Metal combining with a non-metal. Which is, hold on a second. Samosa, bad manners, that's not a good thing. Okay, so your birthday is in between your exam, right? D, correct. Okay, so steel, we have iron and carbon. Carbon is a non-metal, right? Brass, bronze, tell me brass, zinc and copper, and lead or tin? Copper and tin, I believe. I forgot. Copper and tin, tin, not lead. Lead is toxic. You do not use lead actually. Tin. Copper and zinc, brass. Amalgam is any metal plus mercury. Metal plus mercury. Clear? Ma'am, the description says that you are Sonu Sir. Ma'am, it says that you are teaching us math. Hold on a second. Let me check the description. It's not. Why are you lying? Okay, yeah, it is. I'll get it changed. I'll get it changed. My name is not Sonu actually. My name is Ekta. Ekta ma'am.
Yes, this we are following CBSE pattern here.
Color difference, color wise, let me think. Little difference, yes, it is.
There is difference.
Stainless steel. Stainless steel.
Oh, really? That is nice. Mine also, I guess.
Okay. Yes, there is a color difference between Fe2O3 and Fe3O4. One is slightly darker actually, blackish, brown, blackish color, that is Fe3O4, and this could be red or yellow, something, reddish color. Fe2O3 is reddish actually, it is like rust, and then you have Fe3O4, that is like extreme blackish, extreme rust.
Question.
Okay. Next question. Oh, stainless steel is an alloy of iron, chromium and carbon, right? Slight chromium is there in when stainless steel we are talking about, okay? Next is assertion says some metal oxides are amphoteric in nature. Reason says metal oxides show acidic behavior. First of all, we know assertion is true. Some metal oxides are amphoteric in nature because metal oxides can either be basic or amphoteric. Clear? Reason says metallic oxides show acidic behavior. That is incorrect because metallic oxides are all basic in nature. Metallic oxides are all basic in nature. So assertion is true but the reason is false. Assertion is true but the reason is false. That means the correct answer is option C. Assertion is true but reason is false. Next question. In nature, metal P is found in the form of its compounds, and metal Q is found in the free state. You have a metal P and a metal Q. P is found in form of compounds. Q is found in form of what? Free state. In form of its free state. Clear? Now, which of the two will be nearer to the top of activity series? You have a reactivity series, right? So, if we go from above to below, what is happening there? The reactivity of the atoms is decreasing, right? Of these elements, the reactivity is decreasing, right? If the reactivity is decreasing, so what is happening? Initially, at the top of the reactivity series, all these metals or all these elements will exist as their compounds. They will react with the other elements or atoms and form compounds. But as you go down the reactivity series, as the reactivity is decreasing, they will not react with other atoms and thus will exist in free state, and thus will exist in free state. Yes, gold and silver, magnesium and Ag, and yes, silver above, yes, gold below, silver, done. Less reactive won't react with them, they won't. Yes, correct. So that means which will be lying near the top of the activity series? P will be lying at the top of the reactivity series. Next question. A green layer is gradually formed on a copper plate left exposed to air for a week in bathroom. The week spelling is incorrect. For a week in bathroom. What could be this green substance be? So basically a copper plate. You have seen, right? Copper bottle from which we drink water, but never put lemon water in there. Okay? Never put lemon water there. So what happens when you leave a copper plate in bathroom for some time, or you know, that person left it in washroom, right? But if you leave in the air, in the environment or atmosphere, and it gets exposed to air, what happens? So firstly, there is oxygen, right? Copper oxide will form. Now this copper oxide in air or in atmosphere, we have carbon dioxide also, right? And this carbon dioxide, when reacts with copper oxide, we get copper carbonate. Now this copper carbonate is green in color. This copper carbonate is green in color. So that means the substance that is formed, that green layer, is of copper carbonate. This substance is copper carbonate, okay? This green layer is copper carbonate. It's patina. Yes, it is patina. Yes, that means it gets tarnished, and there is one more name, that is patina. Patina, okay? Yes. Clear? Next question. I hope it doesn't fall. Next question. Oh, so big question. The metals produced by various reduction processes are not very pure. The metals produced by various reduction processes are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metal is electrolytic refining. Yes, we know that method, right? So what is the cathode and anode made of in the refining of copper by this process? If you are refining copper, which metal will which will be the anode and which will be the cathode? So simple. The cathode will be of pure copper. Anode will be of impure copper. Impure copper. Second question is, name the solution used in the above process and write its formula. The solution used will be copper sulfate. Solution used will be copper sulfate. Solution means the electrolyte. Solution means the electrolyte. How copper gets refined when electric current is passed in the electrolytic cell? So when you pass the, again I am explaining it, when you pass the electric current, the metal from the anode breaks down, dissolve in the solution. From the solution, an equivalent amount of, okay, if you have problem remembering this word, in place of it, just say equal. An equal amount of metal from the salt solution will deposit on the cathode. From the anode, okay, what happens when electricity is passed? Copper from the anode breaks down and breaks down and goes in the solution, and from the solution an equal amount of metal will deposit on the cathode, and that's how you get your pure metal. You have two beakers, A and B, containing copper sulfate solution. Okay, two beakers have copper sulfate solution. What would be the change observed to 2 hours if you dip strip of zinc in beaker A and strip of silver? So in this one we dipped a zinc strip, and in this one we dipped a silver strip. What will be the observation? As we know, zinc is much more reactive than copper. What will happen? Zinc will displace copper, and on the strip there will be reddish brown deposit of copper. On the strip there will be reddish brown deposit of copper, and in the second case, copper sulfate and silver, as copper is much more reactive than silver, there will be no reaction, there will be no change. So here no change, and in test tube A, reddish brown deposit on the strip, reddish brown deposit on the strip. Clear? Ma'am, what is the aqueous solution made up of? Again, the aqueous solution is made up of copper sulfate. Copper sulfate. Hi, Babita. The aqueous solution is made up of copper sulfate. Okay. Next question. A metal M reacts vigorously with water to form a solution S and a gas G. There is a metal M that reacts vigorously with water and it forms a compound, so forms a solution S and a gas G. This is a gas. The solution S turns red litmus blue. That means the solution S is basic. That means S is basic. Whereas gas G, which is lighter than air, burns with a pop sound. That means G is hydrogen. If it is burning with a pop sound, that means it is hydrogen. Metal M has a low melting point and it is used as a coolant in nuclear reactors. So basically in nuclear reactors you have some compounds that you use to cool the reaction down so that the reaction stops. Okay, it never stops actually, but you add it so that temperature lowers down. And that metal, that solution, that metal is used actually as a coolant in nuclear reactors. Even if you do not remember it, you can still guess it. What is the name of the compound? Okay. So the metal M, as it reacts vigorously, you should know if a metal is reacting vigorously, it is sodium, right? And if it is treated with water, we get sodium hydroxide and hydrogen gas. Now G is hydrogen gas, we already know that, and S is a solution, sodium hydroxide. It is a base, it is basic, right? And it will turn red litmus blue. It will turn red litmus blue. Metal M is sodium, gas G is hydrogen. So that's how you do analytical reasoning. That's how you do analytical reasoning. Hydrogen, because hydrogen is combustible. Yes, pop, it burns with a pop sound. Now before I start the next chapter, do you guys have any doubt in metals and non-metals? Potassium is a possibility, but normally we do not use it. It is highly exothermic, because if sodium is reacting, it's like you get a bomb explosion, right? And if potassium is there, it will react much more vigorously, like explosively. In place of vigorously, the word will be explosively. If potassium is there, potassium reacts vigorously, explosively with water. Potassium reacts explosively with water. Clear? Any doubts you have? Shriveni, we will be doing carbon and its compounds. There it is given. I will explain it. Why are you guys doing time pass? Is it time? You have time to pass. When I had boards, I was studying. Wow, time pass. No, that depends. If you have copper, you are using copper sulfate. If you have zinc, if you want to purify zinc metal, then you will use zinc sulfate. Clear? If you have silver, so either not silver sulfate, we make silver nitrate actually. Silver makes silver nitrate. So it depends accordingly the metal we have, the metal that we are trying to purify. According to that, the salt solution changes. Okay? For copper, copper sulfate, zinc, zinc sulfate, silver, silver nitrate. Clear? Wow. Wow, that is nice. Yeah, nice. Now go here, go there, right? And then your exam, after your exam, you will go here and there for the next year exams. Yeah, do not study. Good one. Okay, yes, you. Nice. There. Okay. So before starting the next chapter, I have a 5-minute break. I'll be back in 5 minutes. Okay, let me write it. After this, we'll start carbon and its compounds. Okay, be back after 5. Whatever doubt you have, type it out. I'll answer your doubt. Okay. Hello. So, it took more than 5 minutes, I believe, but I guess it's okay. You all are still here. Hello, Tasbeel. Yes. Oh, no. I forgot to drink water. Let me stay hydrated. Let's start. Okay, we are starting the last chapter. So, which reaction? You tell me now which reaction you want me to explain. Yes, Neymar Jr. Okay, your name is not Neymar Jr. though. Nripesh. Hi, Nripesh. Hi, Avari. I have already said the name, Neymar Jr., okay? So, yeah. Ronaldo, definitely. Hello, Zainab. Hello, Zainab. Steam, some react with cold water. So the explanation is some metals react with steam and some metals react with water because some metals are more reactive than the other. If the metal is more reactive, it will react with cold water. Okay, but if the metal is not reactive, you need to increase the temperature. You will need to increase the temperature. If you increase the temperature, what will happen? The reaction will happen. Okay. At normal temperature, they will not react. Why? Because they are less reactive. Okay. But if the metal is more reactive, they will react with cold water. Right? For example, if you are hungry, really hungry, you will eat anything. But if you are fully, your tummy is fully, you will go for McDonald's or you will go for Starbucks. Okay. The things like that. So you need to, the selectivity increases, right? Hi, Avari. So that was the thing. Simply, some metals are more reactive. If a metal is more reactive, they will react with cold water. But if the reactivity is less, then what will happen? If the reactivity is less, then you need to increase the temperature because at normal temperature or with cold water, they will not react. But if you increase the temperature, they will react. I hope your doubt is clear. If you have any other doubts, do mention them. Let's start with carbon and its compounds. Okay, just give me a minute. So, carbon and its compounds. Hi, Jenilia. Hi, Jenilia. Hi, Jenilia. Okay, let's study carbon and its compounds. Carbon, it is a non-metal. Carbon is a non-metal. It has an atomic number 6, mass number 12. Okay, that means it has 6 protons and 6 neutrons and also 6 electrons. Okay, carbon has 6 protons, 6 electrons and 6 neutrons. Clear? It shows a valency of 4. That means it forms bond with 4 other atoms. It forms bond with 4 other atoms. It is also called tetravalent. Carbon is also called tetravalent because it forms bond with 4 other atoms. That's why it's called tetravalent. Clear? No, don't say it. It is one of the most scoring chapter actually. The questions come from it major, the case-based questions, or the 3-4 marker question will come. Yes, the most awaited chapter. What's an octet? So octet is Nripesh, right? Octet is having 8 electrons in its in a shell. Okay, basically in the outermost shell, if any atom or element have 8 electrons, having 8 electrons is called octet. Okay, having 8 electrons, octet. Valency of carbon is 4. Yes. Hello Rekha. Okay, so carbon. Okay, we are discussing carbon, right? So carbon has a valency of 4. It needs only 4 electrons, as its electronic configuration is 2 4. It needs only 4 electrons to complete its octet. It needs only 4 electrons, right? So it can either gain these 4 electrons, right, and complete its octet. So by gaining 4 electrons, it will form C4 negative, right? It will form C4 negative. Now think about it. There are 6 protons, right? 6 protons. And if you add 4 more electrons, there will be 10 electrons. 10 electrons and 6 protons. Okay. Do you think these 6 protons can balance these 10 electrons? These 6 protons have the power to attract or balance these 10 electrons? No, right? The atom will be highly unstable. Second thing we can do, we remove these 4 electrons. We just remove these 4 electrons and it have only 2 electrons. 2 means duplet. 2 means duplet. This is called duplet. So that means carbon will have a duplet, right? That is also stable because helium is stable, right? Helium is a noble gas. Similarly, okay, so either it can form duplet or it can form octet. Octet is not possible. Why? Because 6 protons cannot balance the 10 electrons. Second possibility, duplet. If you remove these 4 electrons, what will happen? It is not energetically favorable, my dear kids. You cannot do that. The process requires too much energy. You will need to give too much energy, right? Initially, the 6 protons and 6 electrons are balanced, but after some time, what will happen? When you are trying to remove one more electron, 1 electron will be removed easily. Then after that, if you remove 1 more electron, so we have 6 protons and how much? 4. Actually, yeah, 4 electrons, let's say. Okay, now 6 protons holding on 4 electrons, they are holding them very strongly, so you will need to give very high energy to remove those electrons. So the reaction, that is energetically unfavorable because you need to give too much energy. Okay, you need to give too much energy, and the duplet also is unstable. Why? Because there are 6 protons and how many electrons? 2 electrons. It is highly unstable. 6 protons and 2 electrons is highly unstable. That's why it does not form C4 negative or C4 positive, right? Not the anion, not the cation. What it does, it shares its electron with other similar atoms. It shares its electron with other similar atoms, okay, and form a covalent bond. Covalent bond, that is formed by sharing of electrons. Clear? What other properties it have? It have catenation. Now what is catenation? Catenation means ability of carbon to form bonds with itself and other atoms. It forms long chain of bonds with itself and other atoms. That is called catenation. Okay, catenation means property of carbon to form bonds with itself or other atoms. There are some other atoms which also show this property, catenation, but carbon forms long chain of compounds, long chain of bonds actually, and these bonds are stable. These all bonds are stable. That's why it has millions of compounds. Okay, next is tetravalency. It is tetravalent. That means it forms bond with 4 other atoms. Okay, and also because of that reason it has millions of compounds, because of catenation and because of tetravalency. Now let's discuss these covalent bonds formed by carbon. Covalent bond, a bond formed by sharing of electrons. When non-metal and metal combine, we get ionic bond, right? A bond formed by transfer of electrons. But when there is sharing involved, normally between non-metal and non-metal, when there is sharing involved, the bond formed is covalent bond. Okay, for example, hydrogen and chlorine. Hydrogen has only 1 electron, right? Hydrogen has only 1 electron. Chlorine has 7 electrons. 7 electrons, right? It needs 1 electron and it also needs 1 electron. So they come to a mutual conclusion that I only have 1. I cannot give it to you because obviously then I'll become unstable. Chlorine says I need only 1. Give it to me, either share it with me, okay? So hydrogen and chlorine decides mutually that they will share these electrons. So that hydrogen's octet is complete, and for chlorine also its hydrogen, its duplet is complete, and for chlorine its octet is complete. For chlorine its octet is complete. Similarly in case of carbon dioxide also, okay? Carbon shares its 4 electrons with 2 oxygen atoms, okay? We get double covalent bond. Now, depending on the number of electrons getting shared, covalent bond is of 3 types. Single covalent bond, that is only 1 electron is getting shared between 2 atoms. Double covalent bond, when 2 electrons are getting shared between 2 atoms. Triple covalent bond, when 3 electrons are getting shared between 2 atoms. Yes. Yep. Okay, now what are the properties of these covalent compounds as we discussed for the ionic also? So covalent compounds, they have low melting boiling point, as the bonds are covalent bonds, and these covalent bonds are very weak. They are poor conductor of heat and electricity. Why? They are poor conductor of electricity because they have no ions, because they have no free ions or electrons. They are soluble in organic solvents. Why? Because like dissolves like, as they do not have any charge, positive negative charge, they will dissolve in substances that do not have this positive negative charge. Clear? So they are soluble in organic solvents like benzene, hexane. They are not soluble in water. Next is allotropes. What are allotropes? So allotropes are, firstly, they are made up of same element, but they have different structural form. Allotropes are made up of same element, but they have different structural form, right? Different structural form. So majorly there are 3 allotropes of carbon: diamond, graphite, Buckminster fullerenes. Diamond, graphite, Buckminster fullerenes, okay? So first let's discuss the diamond. Diamond is an allotrope of carbon. Diamond is an allotrope of carbon, right? So it has carbon in this form. Each carbon atom is bonded to 4 other carbons. 4 other carbons, right? Each carbon atom is tetravalent, that is, it is bonded to 4 other carbons, okay? It has this 3D network-like structure. This is 3D network-like structure. Diamond, have you seen it? It has this 3D network-like structure, okay? And it is very hard, okay? One of the hardest substances known to humankind, okay? 3-dimensional arrangement of atoms, and all the atoms are tetravalent, so there are no free electrons, so it does not conduct electricity. Next allotrope is graphite. Graphite is this grayish black opaque thing, okay? Your pencil's tip is made up of graphite, okay? It is soft and slippery to touch. So in graphite, each carbon atom is bonded to 3 other carbons. As you can see, let's see here. This carbon atom is bonded to 1, 2 and 3 carbon atoms. So that means there is 1 free electron. There is 1 free electron. Okay, there is 1 free electron. Now due to this 1 free electron, graphite is able to conduct electricity. Clear? Graphite will conduct electricity due to this 1 free electron. Now why is it soft and slippery to touch? It is soft and slippery to touch because in graphite we have these hexagonal layers. In graphite they have these hexagonal layers that are stacked over each other, right? And there is very weak force of attraction. In between these layers, and since the attraction is very weak, what happens? These layers are very weakly bonded. So whenever little push you do, little force is applied, these layers will slide on top of each other. Yes. Allotropes are out of syllabus or what? So structure is not actually, you might get questions from it and you need to draw it. It's very simple, you can draw it. Yes, you can draw it. Actually it is very easy. This is the structure. You don't need to draw this one. You can draw this one. Okay. Now one free electron is there. Due to this one free electron, they will conduct electricity. And the second reason is these layers will slide off on top of each other. And if they slide off on top of each other, what will happen? They are extremely soft. Due to this reason, they are extremely soft and slippery to touch. Okay, they're extremely soft and slippery to touch. Next, allotrope is Buckminster fullerenes. It looks like this. This is the structure, and it looks like this. Okay, this is a dome-like structure. Okay, this is similar to one building found in USA that is designed by the architect. That was designed by the architect Buckminster fullerenes. So on because of this shape and the name, because of the shape actually it got its name. Okay. Fullerene is hard to draw. You do not need to draw the fullerene. Okay, it won't be asked. Trust me. So U diamond is hard because diamond has a 3D network. It has a 3D network of it has a 3D network like structure, okay, where all carbon atom is tetravalent, okay, when all carbon atom is bonded to 4 other atoms, and due to this 3D network they are extremely hard. They have this 3D network, and because of that they are extremely hard. They are hexagonal yug. Graphite is hexagonal. This is not hexagonal. This is different. Why? Where are you seeing the hexagonal? It's a dome-like structure. Hexagonal is graphite. Graphite has hexagonal layers. Okay. Now what is the formula? C60. It has 60 carbon atoms. Okay. Yeah, that is all. This is what required. That nothing else is required from this one. From graphite and diamond questions might come. This one is very easy and no much questions are asked. I'm not your bro. I'm not. Next is hydrocarbons. Hydrocarbons. What are hydrocarbons? Hydrocarbons have carbon and hydrogen. These are atoms, organic compounds that are made up of hydrogen and carbon. Okay. What is the different type? There are 3 types of hydrocarbons: saturated hydrocarbons, unsaturated hydrocarbons, and cycloalkenes. Okay, saturated hydrocarbons are those hydrocarbons which have carbon-carbon single bond. Carbon-carbon single bond. All the carbon-carbon bonds are single in saturated hydrocarbons. For example, in alkanes. And what is the general formula of alkane? The general formula is CnH2n plus 2. CnH2n plus 2. Then you have unsaturated hydrocarbons. What are unsaturated hydrocarbons? So unsaturated hydrocarbons are those hydrocarbons where you have at least one carbon-carbon double bond or carbon-carbon triple bond. So where there is at least one double or one triple bond there. Either double bond or triple bond. Okay. So alkenes and alkynes, they comes under unsaturated hydrocarbon category. Alkenes and alkynes comes under unsaturated hydrocarbon category. Now what is the general formula of alkene? The general formula of alkene is CnH2n, and the general formula of alkyne is CnH2n minus 2. H2n minus 2. Clear? Cycloalkanes. So what are cycloalkanes? So cycloalkanes are firstly saturated. They are saturated compounds. They comes under the saturated category. Why? Because they have all these single bonds. They have carbon-carbon single bonds only. In cycloalkanes, the difference is all the hydrocarbons are single bonded. Okay, all the carbon and carbon hydrogens are single bonded, but there is a ring or a cycle. A ring or cycle present there. Circle, a ring or a cycle is there, okay, and because of that they are called cycloalkanes. The general formula is CnH2n. Their general formula is CnH2n. Okay. Benzene is in a cycle form, but benzene have double bond. Benzene does not have single bond. It has alternate single and double bond, okay? There is double bond also there. So if double bond is there, it is unsaturated. That makes it unsaturated. Clear? I told you at least, you understand the language, right? At least means there is one, minimum one is there. One double bond or one triple bond is there. That means at least, okay? Yes, benzene is in cycle form. So Shriveni, Nripesh, I believe. So the difference between allotropes and isomers. Allotropes are made up of same element, okay? They are made up of same element, but the structural arrangement is different, okay? That means they have only one element. For example, allotropes of carbon will have carbon only. Allotropes of sulfur will have sulfur only. Clear? Isomers are compounds actually that have same molecular formula. They are compounds. So they have isomers will have carbon, hydrogen, oxygen, you know, more than one atom will be there, more than one element will be there. Clear? And they will be their molecular formula is same. That means the number of carbon, number of hydrogen, number of oxygen, all these will be same, but only the structural arrangement is different. Yeah, the definition is same, that structural arrangement is different, but basic core difference is isomer will have more than one element in them, okay? Allotropes are only made up of one element. Allotropes are only made up of one element, okay? And isomers show different chemical properties, okay? Isomers may show different chemical properties, but allotropes will all have same chemical properties. All allotropes will show similar chemical properties. Clear? I hope it is clear now. Homologous series. Now what is homologous series, ma'am? Homologous series is a series of organic compounds. It is a series of organic compounds that have same functional group, same general formula, same chemical properties. Each successive member differ by CH2 unit, by a CH2 unit, that is 14 atomic mass unit, and they show gradual change in physical properties, okay? So functional group means all will be alkanes, all will be alkenes or alkynes or alcohols, ether, aldehyde, ketone, carboxylic acid. These all are member of same homologous series. These all are the members of same homologous series, as these have same functional group. Second, general formula is also same. For example, the general formula of alkanes is CnH2n plus 2, right? So that means all the atoms that have the same general formula, all the other, you know, C1, C2, C3, N1, N2, N3, they all will be the member of same homologous series, that is alkane, okay, if they have the same general formula. Then they show same chemical properties. Why? Because chemical properties means chemical reactions, and reactions are determined by the functional group present. Reactions are determined by the functional group present. If they have the same functional group, that means they will show the same chemical reactions. So that depends on the functional group. If same functional group is there, so that means the chemical reaction will be same. All the chemical reaction will be same. Physical properties, there is a change in physical properties. Either the physical properties. Firstly, what are physical properties? Melting point, boiling point, molecular mass, these all are physical properties, right? You can see them. Physical properties either will increase or they will decrease. Either they will increase or they will decrease when we are talking about homologous series, okay? So for example, for alkanes, normally what happens whenever we are moving in the homologous series, so say for example from methane, ethane to propane, butane, pentane, right? So what is happening? The molecular mass is increasing, but alongside the molecular mass, we have one more thing, which is the melting boiling point also increases. Melting boiling point also increases. Clear? I hope it is clear. So they show gradual change. These are all the things. They have same functional group, same general formula, same chemical properties. Each successive member differ by a CH2 unit. So if you want to check, you can just write two members. Let me start with the basic one. If I write two members of alkane series, first is CH4 methane, second is C2H6 ethane, right? What is the difference? How much carbon? One carbon. C1, C2, one carbon. How many hydrogens? H6, H4, that means two hydrogens. So each successive member, they belong to the same homologous series, and each successive member has a difference of CH2 unit. What is CH2? Means 14 atomic mass unit. Carbon has a mass of 12 and hydrogen 2. 2 hydrogens means 2, right? So that means it has a difference of 14 atomic mass unit. Clear? That is your homologous series. 9 members are there: alkene, alkyne, alkane, alkene, alkane, alkyne, alkane, alkene, alkyne, alcohol, ketone, aldehyde, carboxylic acid. Okay. Ether is also there. Haloalkane is also there. 9 are there. These 9 are important. Okay. Alkane, alkene, alkyne, haloalkane, alcohol, ether, aldehyde, ketone, carboxylic acid. These all are the member of homologous series, separate homologous series. Okay. Now, how do you name hydrocarbons? How do you name the hydrocarbons? If you have any doubts, you can ask me. Instead of chatting like this, I'll try. Give me some time. Stop spamming, Bagad. I hope that will do. There was one doubt: list of important metals and its AMU. Important metals and AMU, do not need to remember it, firstly. Second thing is, because in your, if any question comes in your exam, you will be given the AMU in your paper itself. You do not need to memorize it. Okay. For the basic one, sodium, you know that is 23, right? For carbon, oxygen, nitrogen, carbon is 12, nitrogen is 28, 14. Nitrogen is 14, oxygen is 16, right? Why are you not reading my comments? I am answering and asking questions. So, Prakash, what was your name? So, tell me the question again. It is getting spammed too much. I am not able to see your comment. I'm sorry. So tell me again. I will answer it. Don't worry. Okay. Now, how do you name hydrocarbons? So, whenever you are naming a hydrocarbon, you do one thing. You start with let's start with naming one here. Okay, let's start by naming this one. Let's start by naming this one. So firstly, what you do, you identify the longest carbon chain. Step 1, identify longest carbon chain. Okay, so in here, if I want to identify the longest carbon chain, let's start with here 1, 2, 3, 4, 5, right? This is the longest carbon chain. Clear? Firstly, start with the substituent. What is the substituent here? This is the substituent here. What is the name of this substituent? It is called methyl. It is called methyl. Okay. Now name the chain, root name. How many carbons are there? 5 carbons are there. So the root name will be pent. What is the functional group? All carbon are single bonded. So that means the functional group is alkane. And for alkane, the secondary suffix or the end name is ane. So simple. Combine all these. At which position we have the substituent? 3-methyl pent, which is your word root. Then there is no primary suffix here because there is no other functional group, only one functional group, which will be your secondary suffix. Pentane. Clear? What do you want me to repeat? H3C, CH3, that is methyl, Halo group. Yes, halochloro. Okay, let's start with, let me give you one other example. Actually, I can just erase this. Okay. Simple one. Let's start with the simple one. If I want to name this, compound Cl, CH2, 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 CH3. So firstly, I'll calculate the longest carbon chain, identify the longest carbon chain. Okay, so this one is the longest, it has around 5 carbons. This is my longest carbon chain. Then I'll start numbering from the functional group. This is my functional group. This is a functional group. Okay, 1, 2, 3, 4, 5. Okay, now for halogens, we add a suffix. Sorry, for halogens, we add a, what did I do? This will go up, up, up. Here. Okay. Yep. We were here. So for halogens, if we have it here, we do not actually. Okay, it got somewhere. Let me do it. Halogens. If halogens are there, that means X is halogen. So we add a subprefix. We add a prefix, which is halo. The prefix is halo. If you have Cl, chloro, Br, bromo, I, iodo, F, fluoro, right? So instead of that compound, that atom, we add chloro, bromo, fluoro, right? Clear? So here also, we start numbering. Firstly, we'll add the prefix. Prefix will be of chloro. Okay. Then after that, root name, word root. What is the word root? Which means the number of carbon chain. There are 5 carbons, right? So for 5 carbon, if C5, 5 carbon are there, the word root is pent. And then you have primary suffix, secondary suffix, depending on the functional group. If 2 functional group are there, then you have a primary suffix, which is the smaller functional group, or you can say the less prioritized functional group. Then you have the more prioritized functional group. Not complicated, you will have only one functional group. So you can just cut this down. You can just say you have a prefix, then you have a word root, prefix, then you have a word root, and then what we have? We will have suffix. This will be the functional group, okay. In some cases, the functional group is here also, okay, prefix. For example, in case of halogens, so the name will be chloropentane. Why ane? Because it is an alkane. I hope it is clear. When H3C is there, the name starts with methyl after chloro. Yes, because in that case CH3 is the substituent. For example, if I just replace this one hydrogen with CH3, so in that case this is your substituent, so you will name it as 3-methyl, and then this prefix will come, 3-methyl chloropentane. 3-methyl chloropentane. Clear? What is 2-methyl butane? 2-methyl butane is a carbon compound. This is the carbon compound, 2-methyl butane. This is 2-methyl butane. If you count the number of carbons, okay, 4, this is the longest carbon chain, and at second position you have a group CH3, which is methyl, okay, and then the parent chain 4 carbon length means but, and then you add the functional group, which is alkane in here. Hi Sagar. This is 2-methyl butane. The branch is in the middle. I want to see, what I am looking for is not the branch. I am looking for the longest carbon chain. The thing is, I am looking for the longest carbon chain. So I'll count where the number of carbon is most. Okay. For example, I could have easily done this thing. Okay. Let me redraw it. Instead of going straight, I could have gone this way. 1, 2, 3, or one more thing I would have done. I would have started from, okay, let's not go there. You will get confused more. Okay, 1, 2, 3, right? But this is not the longest carbon chain. As we know, if we go straight, we have 4 carbons, and 4 is more than 3. 4 is more than 3. That's why we went straight. So we are looking for the longest carbon chain. We are not looking for the substituent, okay? But if the functional group is there, if let's say the Cl is there, so you will count this only, okay? And if the Cl is here, then you will count this only. Okay? In that case, it doesn't matter if it is in the longest carbon chain or not. Firstly, look for the longest carbon chain. If functional group is not in the carbon chain, then look for the carbon chain which have the functional group. That will be your parent chain. Then it will be equal, right? But if the branch is in the middle, then it will be equal, right? It is not equal. How is it equal? Tell me. Okay, let me ask you something. If the compound is like this, first of all, you won't be getting any compound like this. Second thing, if the compound is like this, so you can see that, yes ma'am, this is the longest chain, straight away, right? 1, 2, 3, 4 carbons, but I would say no kid, 1, 2, 3, 4, this is also 4, right? This is also 4. So either you can take this or you can take that one. Now you will take whichever suits you best. So for example, if I did this way, then I'll start from where? Not here actually, I will start from here. Clear? So at 2 I have again a methyl. And how many carbons are there? 4 carbons. Butane. 2-methyl butane. This is 2-methyl butane. Clear? And if I have done it the other way, let's say I did this straight way, same thing will happen. That's why I say if you follow the rules, you will always get the correct name. Let's see. Okay. 1, 2, 3, 4. So again at 2 I have methyl. Again at 2 I have methyl, and the longest carbon chain is 4 carbon, which means but. Functional group is alkane, means ane. So it will be again 2 methyl butane. Clear? How is what possible? What is possible or what is not possible? Why are you fumbling? Why methane doesn't exist? Good question. Very good question. Let me answer you. Like methane doesn't exist. Yeah, methane doesn't exist. Okay, for methane to exist, what is methane, right? Carbon, unsaturated compound, right? Unsaturated compound. That means there is a double bond. That means there is a double bond. And we are talking about methane. We are talking about what? Methane. Methane means there is one carbon. There is only one carbon. So where will be the double bond? Which atom will be on the other side actually? If we are making the double bond, which will be here? Which atom will be here? Hydrogen. Does it look right? Hydrogen will hydrogen form two bonds? Hydrogen has only one electron, right? Hydrogen has only one electron, so it can only form single covalent bond. Clear? It can only form single covalent bond. So two bonds are not possible. Two bonds are not possible in between carbon and hydrogen, and that's why methane does not exist, because only carbon hydrogen can only form single bond, not double bond. And if there is no double bond, so will you find methane? Will you get methane? But if you have ethene, let's see. Ethene means there are two carbons. So yes, it can form single, it can also form double covalent bond, right? So minimum of two carbons are required for forming a double bond, because carbon hydrogen can only form single bond. Carbon hydrogen can only form single bond. There is no double bond forming between them, okay? If you want to form a double bond or a triple bond, you need two carbons at least. So that's why you never find methane or methane. Methane or methane do not exist because there is no double bond between carbon, no double or no triple bond between carbon and hydrogen. There is no double or triple bond between carbon or hydrogen. That's why methane or methane do not exist. Good question. Hold on a second. Yes, correct, Prakash. Hi, Dev. Hi, Dev. Hi, Dev. Hi, Aryan. Yes, tell me what confusion you have. Now, what are these? There are some other functional group with their suffixes here, okay? For example, if you have alcohol, so the suffix is -ol. If you have ketone, the suffix is -on. If you have aldehyde, the suffix is -ale. If you have carboxylic acid, the suffix is -oic acid, okay? If you have alkane, the suffix is -ane, alkene, -ene, alkyne, -wine. Simple. These are the suffix that you need to remember, okay? Yes, tell me your confusion. Can I practice questions from all in one for this chapter? Yes, you can practice questions from all in one. That is good. What do you want me to tell, Aryan? Methane doesn't exist. Yeah. Aryan, you want me to explain methane again? So simple, methane it doesn't exist because carbon and hydrogen cannot form double bond or triple bond. They can only form single bond, okay? When you have methane, that means only one carbon is there. One, C1, okay? One carbon is there, then that's why the root meth is used, okay? Clear? So when carbon and carbon, when methane is there, you means carbon and hydrogen will have a double bond, but that is not possible for carbon and hydrogen. Okay, so that's why methane and methane. Similarly, triple bond is also not possible for carbon and hydrogen. Double bond and triple bond, both are not possible. That's why methane or methane do not exist. Yes, we hit. Yes, we did hit. Now, chemical properties of carbon compounds. So, carbon show majorly 4 type of reactions: combustion, oxidation, addition, substitution. Combustion, oxidation, addition, substitution. Clear? So if we are talking about combustion, so what is combustion? It is the addition of oxygen. Combustion means addition of oxygen, right? Whenever you are adding oxygen, that is called combustion. And when you add oxygen, what happens? You get carbon dioxide, water, heat and light. Carbon dioxide gas is evolved and you get heat and light. So combustion means when you are combusting anything. When you are firing wood, that is combustion. When you are firing, when you are switching on the LPG or the gas cylinder you have, or the gas stove you have, that is combustion. Okay. Then there is oxidation. Whenever combustion happens any way, we get carbon dioxide. The products are same: carbon dioxide, water, heat and light. Carbon dioxide, water, heat and light. Now we just need to balance it depending on the type of carbon compound you have. If you have methane, this is the reaction. If you have ethane, the reaction will be different. Okay, all the carbon compounds, ethane, ethine, you know, alkane, alkene, alkyne, they will undergo combustion. Okay. Then you have oxidation. Oxidation means addition of oxygen in a controlled way. If you add oxygen in a controlled way, that is called oxidation. So we use some oxidizing agent. Oxidizing agent, what are oxidizing agent? The agents which add oxygen. The agents which add oxygen. Right? Like alkaline KMnO4 or acidified K2Cr2O7, these all are oxidizing agents. Okay. So for example, when you do oxidation of ethanol, we get ethanoic acid. This is very important reaction. Oxidation of ethanol will give ethanoic acid. Hi Ashwarya, my name is Ekta ma'am. I don't use Instagram. Yes. Okay, next is substitution reaction. Then there are 2 type of reactions: substitution and addition. Depending on the type of hydrocarbon, they will show the different reaction. For example, substitution reaction are shown by saturated hydrocarbons. Those reactions are shown by saturated hydrocarbons. Clear? Hello Dheeraj. Okay, so oxidation reactions are normally shown by saturated hydrocarbons. That means all the bonds are single bonds. Okay, so what happens? Any other atom comes, substitutes this already present atom, right? For example, when chlorine reacts with methane in presence of sunlight, it replaces one hydrogen. Replaces. Substitute, teacher, you know, right? So it substitutes or replaces the other hydrogen, one hydrogen, and takes its place, CH3Cl, and we get one HCl also. Okay. So saturated hydrocarbons show substitution reaction, and unsaturated hydrocarbons show addition reaction. Addition means they have double bond or triple bond. So there is a possibility you can add hydrogen. You can add any atom. You can add any atom to it, okay? Because there is already double bond, you can break that bond. There is double bond, you can break this bond and add 2 atoms. Clear? If you have triple bond, you can break this bond, add 2 atoms, break this bond, add 2 atoms. Clear? That is addition. For example, this reaction, this is the hydrogenation. This reaction is hydrogenation. So when you have an unsaturated compound, normally we take a vegetable oil which is unsaturated. Vegetable oils are unsaturated, and we add hydrogen, to it. Okay, after adding hydrogen in presence of nickel, platinum, palladium, either nickel catalyst, palladium catalyst, or platinum catalyst, what happens? The unsaturated compound or unsaturated vegetable oil gets converted into saturated fat. It gets converted into saturated fat. This process is majorly used by industries to convert vegetable oil into fat. Clear? What examples are we supposed to know for these properties? Yeah, it is also given in the reaction in that. Yeah, it is also given in that video. So you just need to balance it. For example, combustion, you can also get, let's say, C2H4 also you can get, plus oxygen. If you know the product, carbon dioxide plus water, you just need to balance it. Heat and light also there, plus heat and light. So if you just balance it, two carbons on the reactant side, so 2 carbons here. Now if carbons are balanced, let's see the hydrogen. 4 hydrogens here, only 2 here, so you balance it. Now let's see the oxygen. 2 times 2, 4. 4 plus 2, 6, and here only 2. So that means you need to multiply it with 3. Then carbon, hydrogen, oxygen, that is the sequence you followed, and that's how you balance this equation. Clear? Hello everyone. All the definition methods of carbon, but you ignored me. Yes, no, Prakash, I know you're writing the combustion you wrote, oxidation you wrote, substitution you wrote, addition you wrote. I saw your messages, don't worry. Do it in exams, don't forget till then, okay? Okay. Now the chemical properties of ethanol and ethanoic acid. The chemical properties of ethanol and ethanoic acid. Okay, now ethanol and ethanoic acid. What is ethanol? This is ethanol, right? And this is ethanoic acid. Clear? What are the chemical reactions shown by ethanol and ethanoic acid? What are the chemical reactions? So first reaction is combustion. Ethanol shows combustion. Whenever you have not seen it, but whenever you burn alcohol, it burns with this clean blue flame. That is, it is not visible with our human eyes. You're not able to see. You will not even able to see that flame. You know, if there is a alcohol fire, so you won't be able to see that there is a fire. Okay, it will be burning. You'll feel the heat, but you won't be able to see the fire. It is one of the toughest fire to extinguish. Okay, it's not seen. Yeah, it's not seen. Correct. So ethanol do burn. So whenever you're doing combustion, that means you're adding oxygen, and whenever you're adding oxygen, the products are carbon dioxide and water. So here ethanol. Firstly, okay, one more doubt my students have. I don't know why do they have it. So CH3 CH2OH is this only. How many carbons are there? 2 carbons are there. 3 and 2, 5 oxygens are there, and there is OH. There is OH. This both are same. Clear? These both are same. So when ethanol undergoes combustion, that is reaction with oxygen, it forms carbon dioxide and water, plus heat is released. Not light, but heat is released. Then it reacts with sodium also. When ethanol reacts with sodium, we get sodium ethoxide. This is sodium ethoxide. We get sodium ethoxide plus hydrogen gas is evolved. Whenever we want to see if ethanol is there in a solution or not, we add sodium metal. When we add sodium metal, there is a pop sound. This pop sound is of this hydrogen gas, and that shows that ethanol is present in that solution. Yes, ethanol. Yes, that is correct, Prakash. Okay. Next reaction is oxidation. So whenever oxidation happens, what is oxidation? Oxidation means addition of oxygen. There is one more oxygen. C2H5OH already have one oxygen, right? So you add one more oxygen, and if you add one more oxygen, ethanol, what do we get? We get ethanoic acid. We get ethanoic acid. Clear? So when we add one oxygen, which is oxidation, we get ethanoic acid. Then you have dehydration of ethanol. Dehydration means removal of water molecule. When you remove one water molecule from ethanol, okay, in hot concentrated sulfuric acid at around 443 Kelvin, what happens? Ethanol gets converted into ethene. Ethanol gets converted into ethene. If I have space, I'll show you the reaction though. Somewhere, okay, here I have space. Let's see. So if this is ethanol, and when we add hot concentrated sulfuric acid at around 443 Kelvin, what happens? There is a removal of water molecule, right? So OH and this H gets removed as water molecule, right? And so what happens? This carbon has only like 3 bonds, so they will form a double bond. Actually what happens, it may be a little tricky for you all. This bond goes like this and this bond goes like this. This OH goes out and this H bond will come in, and that's how you get a double bond. And what do we get? Similar, right? Ethene. We get ethene. Similarly, if we have propanol, that is this one. If we have this, again, what will happen? One hydrogen from here, this hydrogen, and this OH will remove, right? Because dehydration is happening, we have a dehydrating agent called sulfuric acid. This will remove, right? And we have a double bond here. So this is propene. Propanol will get converted into propene. Clear? Okay. Now let's talk about ethanoic acid. Again, ethanoic acid also reacts with sodium. It forms sodium ethanoate, and hydrogen gas is evolved. Now how does it react with sodium hydroxide? Now carboxylic acid, ethanoic acid is an acid. Acid and base will give salt and water. So we will get salt and water. They react with sodium carbonate, sodium bicarbonate. As sodium carbonate, bicarbonate are also basic in nature. So what will happen? We will get a salt, which is sodium ethanoate, and carbon dioxide gas is evolved. This gas will give brisk effervescence. What is brisk effervescence? That is bubbling of gas in a solution. In a test tube, when there is bubble of gas getting formed in liquid, in solution, okay, that is called brisk effervescence. So this is an important reaction actually. CH3COH, Na2CO3, what do you get? CH3CONa, the salt. Then you have hydrogen, water plus carbon dioxide. That is not in your syllabus. We are coming to those reactions, don't worry. Ethanoic acid, common name is acetic acid. Next is esterification. Are you guys blind or what? It is written right there. Esterification means when an alcohol and an carboxylic acid. When an alcohol and an acid reacts in presence of acidic medium. When an alcohol and acid reacts in presence of an acidic medium, in presence of acid, okay, or in an acidic medium, we get ester. Simple. That is esterification. So when an alcohol and acid reacts in acidic medium, ester is getting formed. Ester forms. That is called esterification reaction. Clear? This is an ester. CH3COOH, C2H5OH, we will get CH3CO, this OH will get removed here, this H is getting removed, the H from the ethanol will get removed, and let me draw it for you actually. Okay. So if you have an alcohol, this is an alcohol, it reacts with acid. Alcohol reacts with acid in presence of an acidic medium. In presence of an acidic medium, what happens? Let me mark the part that is getting removed. This hydrogen and this OH. This hydrogen and oxygen remove. Okay, it gets removed. Clear? Minus H2O. And if you just join them, if I just join them, let's see, CH3CO, and from here this part O. This is the ester. These are the sweet smelling substances called ester. This is the esterification reaction. So when an acid and alcohol reacts in acidic medium, what do we get? We get an ester and water molecule is removed. Okay. If you just reverse this reaction, that is saponification. If you reverse this reaction, that is saponification. Yes, ester is a functional group, correct. So if you reverse this reaction, let me just write saponification here. It is the reverse of esterification. So when an ester reacts with base. When an ester reacts with base, we get an alcohol and salt of carboxylic acid. Okay, we get alcohol and salt of carboxylic acid. Let me do it. So saponification. Let's say I have an ester, this one. When an ester reacts with a base, let's say sodium hydroxide, we get alcohol, we get an alcohol and sodium salt of carboxylic acid. Sodium salt of carboxylic acid. Clear? So that means the bond broke from here. It breaks from here. ONA, we got ONA, and this H added with this oxygen, right? H. Let me just highlight it a bit. This H came from here, added to this, and we get OH. This is an alcohol, and this is a sodium salt of carboxylic acid. Sodium salt of carboxylic acid. Electron dot structure of S8. It is not required. I am not going to draw it if it is not required. We are preparing solely for your boards. S8 is not required. That's a chair-like structure. You can draw it. This is the S8. 1, 2, 3, 4, 5, 6. S6 this is. Crown-like structure. 1, 2, 3, 4, 5, 6, 7, 8. It is a crown-like structure. It has a crown-like structure, like. This is the structure of S8. Give me 5 minutes. Give me 5 minutes, I'll be back. Huh? Hello. Hello everyone.
Yes, I came as quick as I could.
Let's finish it, shall we? We are almost done actually. We just have some questions left. Let's do those questions and then we can wrap up. Let's start. Actually, it's not done. Hold on a second. Oh. Too fast. Okay, done. So now how do you distinguish between ethanol and ethanoic acid? How do you distinguish between it? Hello everyone. What was your question? S8. I draw the crown now. You saw it. S8. That is a crown-like structure. I'll explain it in the end. Okay. So the difference between ethanol and ethanoic acid is like this. You have two tests, litmus test and sodium bicarbonate test. Okay. Okay, so first test is litmus test. Whenever an acid reacts with, whenever you are treating an acid with litmus, right, what happens? The color changes from blue litmus to red. But ethanol doesn't have any effect because it is not an acid, not a base. Okay. Next is NaHCO3, which is sodium bicarbonate test. So when ethanoic acid reacts with sodium bicarbonate, one gas is evolved. That is called carbon dioxide. Carbon dioxide gas is evolved. But with ethanol there is no reaction. So that is one other test to distinguish between ethanol and ethanoic acid. This is one other test to distinguish between ethanol and ethanoic acid. Clear? Okay. Okay, so where were we? These are the tests that are used to distinguish between ethanol and ethanoic acid. Okay. Now, soaps versus detergents. Soaps versus detergents. Soaps versus detergents, right? Soaps are sodium or potassium salt of long chain carboxylic acid. Soaps are sodium or potassium salt of long chain carboxylic acid, right? They only work in soft water. In hard water, they form scum. Only soap molecules, they only work in soft water, not in hard water, because in hard water they form this insoluble substance called scum. What is scum? So in hard water we have sodium, we have magnesium, calcium salt, right? Now these salts combine with soap and form this insoluble product, insoluble compound called scum. insoluble compound called scum. Clear? Now it has two parts. A soap molecule has two parts, a hydrophilic head and a hydrophobic tail. That means the tail is water fearing. The tail is water fearing. And the head is water loving. The head is water loving. Clear? Detergents, what are detergents? Detergents are ammonium or sulfonate salts of carboxylic acids, right? They work in both hard and soft water. They have the same structure. Now, how do these work? They work by this called micelle formation. They work by the structure called micelle formation. They form a micelle around this dirt particle. They have an oil, we have an oil dirt particle, right? Around this, the soap molecules align themselves in such a way that their hydrophobic tail is towards the oil or grease particle, and their hydrophilic head, their water-loving head, are outside pointing towards the water, right? Now this is micelle. Now how do you separate micelle from your clothes? You by agitation, you roughly, physically, very hardly, rub them or wash them in excess of water, right? And then wash them in excess of water so that this micelle washes away, okay? That is, that is how micelle work. That is how soaps clean actually. Okay, now let's start with the questions, I believe. First question: covalent compounds like methane, ethane and ethanol generally have low melting boiling point. The intermolecular force of attraction between the molecule of covalent compounds are very weak. Yes, it is important. Yes, it is important. The diagram is important. Hi Meenakshi. Yeah, it looks like sponge. Okay, so assertion says covalent compounds have low melting boiling point, and reason says the intermolecular force of attraction between the covalent compound are very weak. Yes, because the intermolecular attraction between the covalent compound is very weak, because of that reason, these compounds have low melting and boiling point. Correct answer is option A. Typically hard, ma'am. I generally confuse option A and B. So, Shivani, for this, do one thing. Whenever you're answering assertion reason based question, add a because. After the assertion, add a because, and then say your reason. If it makes sense, if your reason is explaining the assertion after adding the because, then your assertion is and reason. Your reason is the correct explanation of the assertion. Okay, so always add a because, or if you have reason, then do the reason, read the reason, and that is why, and add that is why. That is why assertion. Okay, assertion, add because, say the reason. If it makes sense, then it is. If it makes sense, then it is correct. Okay, if you say reason, add that is why, say the assertion. If it makes sense, if it is correct, then your answer is correct. Then option A is correct. Both assertion, reason are true, and reason is the correct explanation of assertion. That's how you solve all the assertion reason questions, not in just chemistry, in each subject. Correct? Okay, next question. Assertion says an aqueous solution of ethene will decolorize bromine water. There is a test called bromine water test. The test is called bromine water test. Now what is this test? You have bromine water, which is reddish brown in color. Bromine water is reddish brown in color. Okay. Now bromine water is reddish brown in color. If you add bromine water to a saturated compound, if you have a saturated compound and if you add bromine water to it, what happens? What happens actually? The bromine water retain its color. It will stay as reddish brown only, retain its color. But if you add bromine water to unsaturated compound, what will happen? Bromine water will lose its color. It will lose its color and it will get converted what? Colorless. It will be colorless, not reddish brown. It will be colorless. Clear? So assertion says an aqueous solution of ethene will decolorize bromine water. Yes, because ethene is what? Unsaturated compound. Ethene is unsaturated compound. That means assertion is true. Now let's see the reason. Because ethene is an unsaturated hydrocarbon and readily undergo addition reaction with bromine. Yes, that is correct. So the correct answer is option number A, not B. It is option number A because reason is the correct explanation. Yes, correct. Next question. Assertion says butane 1-ol and butane 2-ol exhibit similar chemical properties because both are alcohol, so they will exhibit same chemical properties. Reason says they belong to the same homologous series of alcohol and possess the same functional group. Correct. Simple. Assertion and reason is correct. Both are true, and reason is the correct explanation because as butane 1-ol and butane 2-ol, they belong to the same functional group. They belong to the same functional group and same series of alcohol. Okay, because of that they show similar chemical properties. Because of that reason they show similar chemical properties. Next question. The complete combustion of hydrocarbons like methane produces carbon dioxide and water. Correct. When you burn methane, when you combust methane, yes, we get carbon dioxide and water. Reason says the incomplete combustion of hydrocarbons in a limited supply of air can produce carbon monoxide. Yes, when you have limited oxygen supply, instead of getting carbon dioxide, we get carbon monoxide. Okay, that's why it is said yes. The correct answer is option. No one is answering. The correct answer is option number A. Actually, no. The correct answer is not option number A. The correct answer is option B. Because yes, assertion is true, yes, the reason is correct, but if you add the because, so yes, the complete combustion, assertion is talking about complete combustion, reason is talking about incomplete combustion. Both are different. That means reason assertion is correct, but reason is not the correct explanation of assertion. The correct answer is option B. Yes, option B, correct. Next question. Assertion says alkanes are generally considered chemically unreactive. Yes, they are chemically unreactive. Why? Because they have all the bonds complete. They have 4 bonds. They have completed their bonds. Reason says alkanes are saturated hydrocarbons containing only strong CC bond and CH single bond, which are difficult to break. Correct. Because, if you add the because and then you say the reason, it makes sense. Because, yes, alkanes are saturated hydrocarbons. That means they have carbon-carbon single bond and carbon-hydrogen single bond, which are difficult to break. And because of that reason, alkanes are unreactive. See, I added because, then said the reason, it made sense. But if I said the reason and added that is why and said the assertion, it also made sense. So that means both assertion and reason are true, and reason is the correct explanation of assertion. Next question. Ethanol is an important industrial compound. Balanced chemical equation for the complete combustion. This is the complete combustion of ethanol. C2H5OH. If we add oxygen, we get CO2 plus H2O plus heat, and heat is there. So I'll just add 2 here. Carbon is balanced. Hydrogen, let's see, 5, 6 hydrogens here, 2 here, 3 hydrogens balanced, 3 oxygens. Now here we have 4 and 4 plus 3, 7 oxygens. 2 and 3 oxygens here, 5, 6, 6, 3, 2, that is 4 plus 7. Double it, 14. The reaction was not like that. One second. Yep. Yes, 6 and 7, and now it is 7 also. Correct. Next question is what happens when ethanol is heated with excess concentrated sulfuric acid at around 443 Kelvin. So again, dehydration. The reaction that happens is dehydration reaction. Okay, and write the chemical reaction. So if you have ethanol and add a dehydrating agent, hot concentrated sulfuric acid at 443 Kelvin, what will happen? Ethene formation will happen. Okay, and water molecule is lost. That is the balanced chemical equation. Next is what happens when ethanol is warmed with ethanoic acid in presence of a few drops of concentrated sulfuric acid. So again, an acid plus alcohol. An acid plus alcohol in presence of acidic medium, what will happen in presence of acidic medium? We get an ester. We get an ester. CH3COO C2H5 plus H2O. This reaction is called esterification. Esterification, again, ethanol is used as a solvent and for making medicines. That are its two applications. Next question. Assertion says ethanoic acid reacts with sodium carbonate to produce carbon dioxide gas with brisk effervescence. That is correct. Reason says all organic compounds that contain a carboxyl functional group are acidic in nature. All the organic compounds that contain carboxyl functional group are acidic in nature. That is also correct. But does the reason explains the assertion? See, because ethanoic acid reacts with sodium carbonate to produce carbon dioxide gas with brisk effervescence, because all organic compounds that contain a carboxyl functional group are acidic in nature. Both are true, but they do not explain it. Both are true, but they do not explain it. So that means the correct answer is option B. Both are true, but reason is not the correct explanation of assertion. Okay. Next question. The organic compound propanone contains which of the following functional group? Propanone, that means it is a ketone. That means it is a ketone. So correct answer is option D, ketone. Clear? Next question. Assertion says soaps are not effective cleansing agents in hard water. Soaps are not effective cleaning agents in hard water. Reason says because soap forms insoluble precipitates with calcium and magnesium ions present in hard water. Correct. Yes, that is the reason. And what is that product? That product is called scum. So yes, assertion is true, reason is true, and reason is the correct explanation of assertion. Because I added the because. Why are there so less number of likes? Why are you guys not liking the session? Why are you not liking it? Like the session. Brisk effervescence. Again, brisk effervescence mean in a liquid solution when there are gaseous bubbles. Gases are there. That is called brisk effervescence. Bubbling of gases is called brisk effervescence. Okay? Everyone go and like the session now. Okay? You guys are just talking. No one is liking the session. Next question. Assertion says when ethanol is heated at 443 Kelvin with excess concentrated sulfuric acid, ethene is obtained. Yes, that is correct. Reason says concentrated H2SO4 acts as a dehydrating agent. Yes, correct. Because concentrated sulfuric acid acts as a dehydrating agent, and because of that reason, when ethanol is heated at around 443 Kelvin in presence of concentrated sulfuric acid, ethene is obtained. Correct. So that means both assertion and reason are true, and reason is the correct explanation of assertion. Good, Gayatri. Yes. So everyone please go and like the session. Yes, if you are enjoying it or you are just chatting here. Next question. Two carbon compounds X and Y have the formula C4H8 and C5H12. Which one of the following is most likely to show addition reaction? As you guys remember, addition reaction is shown by compounds. Addition reaction is shown by unsaturated compounds. Compounds. Now, which between these which is unsaturated? C4H8 or C5H12? This is pentane. This is pentane, and this is what? Butene. CnH2n. This is CnH2n plus 2. So this is ethene, right? This is butene. And butene is an unsaturated compound. So they will show addition reaction. Okay, next question. Write the electron dot structure of methane and ethane. Let me draw it. Methane. This is methane, and let me draw the ethane one also. This is for methane. And this is for ethane. CH4 and C2, CH3 or C2H6. Single bond, yes, but it is electron dot structure. So instead of bonds, we are showing the electrons. X is the electron of hydrogen and dot is the electron of carbon. Next question. Draw the structure of missile formation when missile formed when soap is dissolved in water. Clearly label the hydrophobic. So let me draw it. We have oil or dirt. Okay, around it, these are the soap molecules. This is the hydrophilic head, which is the water-loving head. And this is the water-fearing hydrophobic tail. Okay, this is missile. Now with the help of missile structure, explain the cleansing action. Simple. Whenever an oil dirt particle is there, soap molecule align themselves in such a way that the hydrophilic part is pointing outward towards the water and the hydrophobic part attaches itself to the oil or dirt surface, and that is missile formation. Okay, after that you agitate the mixture. After that you agitate the cloth or physically do something with it, hit it hard. What happens, this missile gets separated from the clothes and then you wash it away with excess of water. Why they are not effective cleansing agent in hard water? Because in hard water we have magnesium calcium ions, and these magnesium calcium ions react with the soap and form this insoluble product called scum. Clear? Next question. Which of the following does not belong to the same homologous series? Which of the following does not have the same general formula? Let's see. Methane, C2H6, C3H8, C4H8. C4H8 is alkyne, CnH2n. This is CnH2n plus 2. This is CnH2n plus 2. This is again CnH2n plus 2. So only one is there which has a different general formula. This one is alkene. So the only different one which does not belong in the same homologous series is alkene. That was all. Actually, if you guys have any doubts, we have done this. If you guys have any doubts, do let me know. Okay? And if you do not, then like the session, subscribe the channel and stay connected for such interesting sessions, and all the best for your boards. If you have any doubts, I'm waiting for 2 minutes and then I'll end the live. Homologous series because it will come in unsaturated. C3H8, count it. C3H8, C3H8. Where was C3H8? It was C2H6. Let me see. Where was C3H8? H2n plus 2. It is saturated. No? It is saturated compound. It is a saturated compound. Where are you seeing the unsaturation? Bye everyone. Okay, that was it. Yeah, everyone present, please like the session. Okay, take care.